Hello, and welcome to my first attempt at a YouTube video. My name is Dave, and if you can't guess from the name of this video, channel, and accent, this video is about retro speakers, and I am very much a Bristolian. This is a new experience for me, but hopefully something that can be informative and enjoyable for both me and you, the viewers. Disclaimer: I am not a professional electronics engineer. Before we begin, I would just like to make it clear that I am not a professional at electronics or speaker repair. This is a hobby and something I do in my spare time. This video is not sponsored in any way, and all opinions voiced in the video are my own and should be treated as such. Whilst I will endeavour to be as accurate with the information shared, there is always possibility for inaccuracies and room for improvement. As always, constructive feedback is welcomed, and if there are questions, please leave them in the comments section below, and I'll do my best to get back to them. As a second disclaimer, if you haven't already guessed by what is on screen now, I work in IT, and you absolutely cannot work in IT without a little bit of death by PowerPoint. If you can't wait, I'll put a skip to repair button now. With that out of the way, let's get on with it. If you're here watching this video, I will assume you are familiar with the great products that Bang Olufsen have produced over the years. And for that reason, the Beolab Penta should require no introduction. However, for those interested in a more in-depth review of the speakers, this will be available in a follow-up video. Before I jump into the disassembly and servicing of my own Beolab Penta 2s, I just want to review and share with you some important information which will assist with our overall understanding of the speakers and the differences over its 13-year production run. The Beolab Penta came in 3 major revisions. Within these revisions, there are a few differences. For example, regional differences in terms of how the internal power supply wiring was configured, different colour and type of displays, as well as a different range of audio connections. In this video, I'm hoping to cover off some of the common faults I'm aware of and some key recommended servicing steps to repair and stop further degradation and damage to your speakers. Common faults I'm aware of are speaker amp standby light not lit, where the amp appears to not power on and is completely dead. This is the fault one of my Penta 2 amps has, and the primary reason for this video. The other issue is speaker amp standby light lit red, however upon turning the speakers on it goes green temporarily and then clicks off, displaying a yellow light. This is the reason I rebuilt one of my friend's Penta 1 amplifiers. And the last one I'm aware of here is muffled sound, audible crackling, hissing after an hour or so usage, and this is why I rebuilt my friend's other Penta 1 amp. The other issue I've noticed with my amplifiers at the time was that they got overly warm and there was a cracking sound from the heatsink due to the heat. This is something that both of them were experiencing. So as you're about to find out, this video was filmed over multiple days and took a lot longer than I anticipated initially. But we're going to cover a lot of information and I hope it's of use to you. We're going to cover multiple servicing items. Some I have performed on a pair of Penta 1s previously, and some will be new to me as well. In this video, I want to cover the rewire and replace of the plug, the replacement plug fuse, checking and replacing internal glass fuses where necessary, replacing the main PCB electrolytic capacitors, trim pots, the OPAMP chip and a socket, the 6 large transistors. The reason for this is that's what failed in the Penta 1s. Renewing all the heatsink paste, and finally replacing the 2 big capacitors in the power supply. In order to prepare for the recording of this repair work, I decided to revisit the service manuals. I will host copies of these and any other source material I refer to on my website, and links will be available in the description. On screen now is a small summary of the power supply regional and generational differences. If you are unsure of which version of speaker you have, you should be able to work this out by looking at the information printed on the rear panel of the amplifiers. I will demonstrate this later in the video. Once you know which type number speaker you have, you should be able to refer to the on-screen chart and establish which glass fuses you will require should your amplifier have a fault that is blowing a fuse. Upon collating this information, I found it interesting to note that on the Penta 1 in Japan, they decided on a higher milliamp fuse than in the later models. This may be something owners of the Japanese variant need to consider. If you require to purchase a new fuse, it will be important to remember that the fuses listed starts with a T for time delay or slow blow. Fuse part numbers with an F denotation represents a fast blow fuse. As far as I'm aware, those are not required in these amplifiers. Whilst also reading the service manuals, I took the opportunity to review the electrolytic capacitors listed for the main PCB, and this is on the screen now. There are two interesting things to note here. One, sadly I haven't got a column for the Penta 3. When looking online, I have been unable to find a complete service manual. Supposedly the Penta 3 amp is identical to the Penta 2 amp, but having never seen one, I'm unable to confirm this. The second interesting thing to note is that in reality, when I looked at my notes for the Penta 1 amplifiers I recapped, they were actually spec'd like a Penta 2 amplifier, with a 100 microfarad capacitor in the place of C20. If you purchase the recap kit from Martin at the BO Parts shop, you will see options are included to cover both eventualities. If you are purchasing your own capacitors, it is important to meet or exceed the quality of the original capacitors. Originally, Bang Olufsen used 85-degree caps, but it's now commonplace and recommended to use 105-degree Celsius caps for longevity of the repair. Finally on the screen are the remaining components I plan to replace in this video, excluding glass fuses and the large power supply capacitors. So all told, we will be replacing 27 components, checking 2 glass fuses and potentially 1 plug fuse. With most of the theory and preparation reading out of the way, let's get to the first task, disassembling the speaker and bringing the amp to the bench.
Okay guys, so I'm just here in the spare room in the house and I've got the Beolab Penta on its back on a duvet on the bed, and I'm just looking at the base. I've got 5 little nuts, and these are 7mm. I've just got a deep reach socket here from a cheap socket set, and these aren't that tight, so I can just undo these by hand, just put them safely. And I believe when I remove these, there will be another set that actually secure the amp to the speaker, stop the amp coming away, but we shall see when I remove this base in a moment. So that's the base now loose. Obviously you've got the power cable here, so just be careful of that, and the base will just lift away gently. I'll feed the power cable through it, just drop that down, put the base on the floor, and yeah, as I said, there's 5 nuts still holding the amp to the speaker, so I'll just repeat the process. And what you'll end up with is 5 quite long spikes hanging out of the speaker. So whilst you're working on the speaker, or on the amplifier rather, you just want to be careful of those. Make sure you don't bend them, make sure you don't catch them on anything, damage the speaker. It may be worth taking them out if you're going to be leaving it like that for a while. When you get towards the end of these nuts, you want to support the amp. Okay, and I'm just going to lift that away, nice and square. And what you'll find is there's some speaker connections which need to be disconnected next. So I'm going to push the amp back, and I'm just going to change the camera angle. Okay, so hopefully you can see from the new camera angle what I mean. We've now got the spokes, which are the dangerous bits, and we've got two speaker cables connecting to the speaker itself, and then we've got a DIN plug, which is the display side of it. The DIN plug simply removes, see if I can do it with this hand. Yep. And then the terminals just unscrew counterclockwise. Now, just in case you're unsure which cables to go back, I'm just going to put a little bit of black on the cable that goes to the black terminal, just so I remember which is which. I will just unscrew those now, which usually for disassembly they don't have to unscrew all the way, but for assembly it can help. And yep, they've just come out. And yeah, the identification of that cable isn't obvious here, but I'll show it later. Now simply pull the amp off, and that's the amp removed. Okay, so here we are with the amp back on the bench, dust and all. So this has been sat broken for a little while, hence the dust. And apologies for the state of place. We are renovating this house, so just bear with that. So before we go any further, a few things to note. We've obviously got the little nuts that we took off when we removed the amplifier from the speaker. So I like to use these little IKEA food bags, something like this, the smaller one, or perhaps the slightly bigger one. I'll go for the bigger one, I think. So I will just pop these nuts in there, because the worst thing is to lose something, and when you go to reassemble you realise that you can't find it. So let's put those safe in there for now. The next thing I would suggest is you're probably not going to plug the amplifier in just yet, but you have to be careful of the speaker terminals or the speaker cable ends. Just use a bit of electrical tape to cover those up when you get closer to the time. With my amplifier, this is the UK one, or the GB one, and I can tell that for a few reasons. One, there's a 3-pin plug. Second, if you look at the back of the amplifier, they silk screen on the back what it is. It says there it's a 6622, which if you look at the spreadsheet that I've provided, that denotes it's the UK one. And also on the front edge of it, you've also got the serial number there and the type number there as well. And I can tell from the serial number starting with an 08 that this is actually a 91 produced speaker. Now the first job that I want to attempt is simply checking the plug, checking the fuse. Now if we look at this plug, there's something a little bit odd about it. It's pretty rattly where it's old and worn, but it's got some rust on the screws, which is not ideal. And I don't believe this is going to be the original plug from B&O. And the reason for that is that if you look at the pins, they're brass all the way down. And there was actually an amendment to the British standard which said that for safety reasons these had to be sleeved. So what I'm going to do is I'm going to replace this plug. And I have here a brand new plug straight off of Amazon. I'll put some links in the description. And you can see that these have sleeves. So this is technically a safer plug, so that when you go to pull it out of the wall, you can't accidentally touch a live component. That's the idea, that when you do that. Whereas with this, if you're a little bit drunk or something, you could get a nasty shock. So I'm going to replace this plug today. So let's have a look. Just got a standard flathead screwdriver. I just so happen to have electrician's screwdrivers. And what we're trying to do here is replace the plug for safety, check the wiring, and also check the fuse, because if you're lucky, it may just be a blown fuse. So we have a look in here, what have we got? We've got a 5 amp fuse, which I think these should be 3 amp, because in the UK, the internal fuse is a 2 amp glass fuse. I will check that, but I would suspect that should be a 3 amp. Obviously we've got a live on neutral, there is no earth connection on these devices. Looking at it, you can see that the cables aren't ferruled. There's a little bit of copper on show, maybe a little bit of a tight bend on the neutral there. But other than that, it's not overly bad, it's just an unsafe, non-current regulation standards plug. So I'm going to replace this. So I will pop the fuse. And just remove the pins from the plug. Undo the cables. And get ready to show you how I intend to fit the new plug. And I'll be back with you in a second. Okay, so I've just had a quick look online, and it seems that people are saying 5 amp would be fine, but as I say, I'm not convinced on that, so we'll see how that pans out. But one thing I should have said is, obviously the point of this part of the video is to say, is it the fuse that's blown in the plug? There's 2 ways to check that. You can simplistically change the fuse, so you can just pop down to your local supermarket and get a pack of fuses. This is 3, 5 and 13, and try that if it's a new fuse. But the better way to do it is, if you can, is just get a cheap multimeter. As you can see, this is a B&Q special. And on the multimeter, you'll see you'll have something that looks like a little speaker or a little sound wave, and that's usually continuity. And you just change it to that. Test your pins. So that means that there's a connection, and then take your fuse from the plug and just hold one pin on one side and touch the other side. If you get continuity, it's not popped. So check the fuse. So in this case, I know that the reason this amp doesn't turn on is not the fuse in the plug. So I know that even if I replaced it, it wouldn't matter. So that's something to bear in mind. There's clearly an internal fault. Perhaps the internal fuse is blown. We will look into that. Okay, so the next thing I want to do is tidy up this wiring in the plug. Now, I want to check to make sure that there's no damage to it. I can see on that neutral there's a little bit of wear where it was rubbing on that internal plug casing. And there doesn't appear to be any cuts to the sleeving at all, but it's not the neatest job, and I want to fit ferrules for a better connection so that you don't get what you get here. For example, you see with the live cable, you can see that there's like a flat spot on it where the screw is pushed down on it, and that could crush some of the copper and make a bad connection. So I'll just do this a bit tidier. So what I'll do is I'll just take my side cutters, just cut the cable. I'll take a pair of wire strippers and just strip some of the black sleeving back off to get some clean cable. And to comply with standards, the live cable should always be a bit shorter than the neutral cable, so that if anybody did manage to pull the cable out of the plug, the live cable would detach first, so it's a safety thing. So let's open up this plug. Some plugs come with a cardboard guide on what length to cut the cables to. This one doesn't. So we'll just take all of the relevant components apart. Let's pop that screw out, pop the fuse out as well. And I'll just do a by eye and see kind of what length I want these cables at. So I would say neutral. I'll probably leave neutral alone first. Probably do the live, come nice up. So I'd say about there. And then what you want to do is just strip a little bit of sleeving off. We'll go there. And if you didn't have ferrules, you would probably just twist that, but I am going to fit a ferrule, and I'll show you that next. So usually you can get these type of ferrules, which are what they call bootlace ferrules, because they've got a sort of look like a bootlace. I like keeping this kit around because if you actually open the lid, it tells you what the different sizes of cable are for the relevant ferrules. So I can see here I've got red is the 1mm and grey is the 0.75mm. And if I just try a red ferrule on this cable, it's actually quite loose. And I know from past experience that if I crimped that down, that wouldn't grip the cable. So I believe this to be 0.75mm cable. And the fact that that grey one fits on there quite nicely proves that to me. But we're not going to use these type of ferrules because with the bootlace it makes it awkward in the plug. So I had an Amazon delivery the other day, which is this little pot of ferrules here. So I just need to work out which is the 0.75mm and fit that ferrule. So I'm just going to try eyeing up some of these. That looks like that could be the one. And there's a tapered edge. It's hard to see. I'll see if I can get this close to the camera. Ooh. Yeah, there's a little taper just on that edge, and that's the edge that goes towards the sheathing of the cable. So you need to try and get all of the strands of the cable in. Yep, that looks good. Looks perfect actually. And then you just get your ferrule crimpers, which this was a kit I got on Amazon. Again, I'll put some links in the description. And you just want to push the ferrule up tight, crimp, and then you get a nice consistent cable there, which we can use to put in the plug. Now, yep, this does support cross and flat heads. So just undo the screw all the way there. And I'll just see what this looks like in this. And I can see that it's going to be a little bit long. So I'm probably just going to take maybe the last one section or the last two sections off of this. Yep, I'm quite happy that that was sitting there. It won't foul anywhere, and that will work quite nicely in the plug. So I'll just do the same with the neutral now. Just put that in there to see kind of where I'm at. And I think with the neutral, probably about there will do it. And I'll just do the same thing. I'll just strip a little bit of sleeving off. I'll just find another one of those 75mm bootlaces, or sorry, ferrules. Yep, work out which way around it is. Try and get all of them. I've missed one there. There we go. Get all of the strands. And what I was doing there is I was just putting it in, putting it into the crimper and tightening it slowly until it pinched, and then just pushing the cable so I know it's tight. There we go. And then again I will just cut the last 2 bits off there. And that's my cables. And as you can see, the live is shorter than the neutral, so if you ever pulled on it, that will come out. Okay, so here we go. I've terminated the plug and fitted that 3-amp fuse we spoke about. As you can see, there's no copper showing on the live or the neutral. They're all nice and tight. You can give the cable a good tug, and the cable relief is working well, so I'm happy that this plug is to today's standards and terminated nicely with the hopefully correct fuse in there. So we'll pop the lid back on that one. Just pop the screw back in. And at this stage, if you thought that was your issue, you could, of course, go ahead, reassemble the speaker and test your amplifier. Arguably, if you protected the speaker ends, you could plug the amp in without the speaker, just to see if it comes on to standby. I won't be doing that because I know that's not my issue. I know there's not a 13-amp fuse in there, so I will take that sticker off. And that's the plug change completed. Okay, so we're now going to flip the amp onto its back, and we need to remove this base plate here to get at the next part of the amplifier. So I've changed my screwdriver over to a Phillips. These screws are not posi, they are Phillips. So I will just start removing them. You're looking for the 5 main screws, and I think there's 2 additional at the back. Yes, there is. And yeah, you can see that's Phillips. So we'll remove the 5 main ones, and these screws are screwing into metal. They're self-tapped, sort of, but the 5 main ones are into metal, and the 2 additional ones are a different type of screw. You'll see that in a second. So I'll just get to that. That's, if somebody hasn't been mucking about with this amplifier in the past. Excuse me. There's 3 screws on the base, plus the 2 additional. The 2 additional are what hold part of the power cable, which we'll see that in a second. You see they're a different type of screw. And the ones that go into the plastic are blunt, so just make sure that you recognise the difference when it comes to reassembly. And then this panel, obviously move it along the power cable, but I would probably leave it on it because otherwise you'll forget to thread it through when it comes to reassembly. Now, there's a few interesting things to note before we go any further. You can see that's where those flat blunt screws go in there into this plastic component here. But the Penta 2 is marginally different to a Penta 1. You have dual power link, which you don't have obviously on the Penta 1. You have speaker terminals instead, alongside the speaker link and the line in. But you also have this additional ribbon here, which was a surprise to me when I opened this, because the Penta ones don't have that. I'm not sure I recall seeing these crystal resistors like that, but it's been some time since I've looked at that, so that's just something to bear in mind. Once the base is off like that, the next thing to do really is take the top panel off. So we will just do that. And this is the same as the bottom. There's 3 screws holding it on. This is the sharp type again. And just make sure that you put your screws in your little bag of components so that you don't lose them. And then this top panel just lifts off. And just be careful to remember to thread this cable through this hole here upon the assembly. So let's just take that one off now. And there you can see the main power transformer. And interestingly, it looks like, yeah, there's just a little cable guard here, little metal piece with some rubber on it, just to tuck these cables back. The Penta ones didn't have that, so that was obviously a design improvement. And the next job is to check the glass fuses. So to get to the glass fuses, hopefully this screwdriver will fit. Yes, it will. You just take this middle screw out here. This is a different size to the other screws, so it's quite easy to work out where it goes. And then the connections will lift, or the cover will lift, sorry, and we will expose the ends of the power cable to there. Excuse the camera wobble, sorry about that. The glass fuses and the ends of the transformer wirings. This piece has 2 little plastic clips, and it just clips over the base of this this covering here, and you just need to gently unclip it by hand, just a little bit of force. It should just pop. There we go. You just want to be a bit gentle with that, because if you snap it, it's going to be annoying. It's old, can't get the part. So there you go, you saw it was a bit awkward, but it did just release. So now I can see my 2 internal glass fuses. And what I would suggest here is you just want a flat bladed screwdriver. So I just get my flat blade again. And you just want to lift these fuses off on one end. So we'll just pop them out on one end. There we go. And that's fine, that's enough. And then just reintroduce the multimeter. Back to continuity. Check your pins. And just check your fuses. So I'll do the top one first, which is the 2 amp. And we can see that one's fine. And then we'll just do the lower one, which is the 40 milliamp. Oh, sorry, 40 milliamp. Oh dear. So in my case, which I knew this, the 40 milliamp fuse has blown. So that's an indicator that there's a problem here. There we go. So the reason that I left the fuses out there is because I just don't want to have a false positive in some way across the holders. So I just do that. So I know that that one's faulty in some way, or been blowing because of a fault. So that's fine. So I will leave them, actually I'll leave them lifted for the moment. Because now I could replace that fuse, fit a new glass fuse, and I will put a link to where you can get those. But the likelihood is that there's something going on in the amp which is continually blowing that fuse. And in my case, I did replace it hoping that the amp would come back to life, and it didn't. It blew the fuse within 10 seconds, so I know there's a fault. So that would be how you would replace the glass fuse, and then you will reassemble the amp and retest it. Okay, so now I'm going to move on to what you would do if you want to replace all the electrolytic capacitors in this amplifier. And unfortunately, you need to get to both sides of the PCB. You need to get to the underside to desolder them, and you need to get to the top side to remove them and replace them. In order to do that, you need to pull this Goliath of a transformer out, and we'll move on to how you do that next. Okay, so we now have the transformer, or sorry, the amplifier turned around, and we need to remove the Torx screws which hold the transformer into the main body. You've got 1, 2, 3, 4 Torx screws, and it looks like they are a T10. So I will change over my screwdriver end, and I'll just do this one down here. Yeah, feels like a T10, and yeah, there we go. Just gently ease it undone. And I'll just stop there for the moment. Now, you've got two at the top here, and you notice they're under these retainers, shall we say, of the front door. And you've got to be very careful not to snap these, because these are quite brittle due to the age, and they're also quite fiddly. Now, depending on how far you're going with the disassembly of the amplifier would depend on what you would do. Normally at this stage I would just try and proceed to removing the door, but I'll assume that you're not going to do the transistors and you're just trying to do the capacitors at this stage. So how I did this when I did this last time is you open the door, and then you need, at this stage, you could now gain access to the screws. I think we'll do that, and I'll come back to how you remove the door a bit later on. So you see I'm just applying a little bit of force, just progressively, because I don't want to shear anything. So that would be the worst result. I'll just pull this cable retainer back, just gently pull those cables back, there we go. There we go, I'll just hold the transformer and just remove these screws. And there's some little washers, and underneath that will be some little rubber grommets which hold the transformer steady. Which those are available, I believe, but you just ideally don't want to lose the ones that you have. So now you can just gently try and lift this out, just to see what it looks like underneath. There we go. And this is the bulk of the weight of the amplifier, to be honest with you. So just try and carefully put it like that. There we go. And inside, if I can just rotate it slightly, I'll come in for a closer look in a second, but there is there's a cable tie holding a lot of the cables together, and just up from that is a little plastic clip, and that's holding the cables to the body of the amplifier. And I didn't realise this the first time I did this, but you've got to remember that the clip isn't going around all of them. When it comes to reassembly, that's really annoying if you believe that that's the case, when it isn't, because the clip doesn't fit and it doesn't fully clip back. And that took me a little while to realise that, because I didn't have some pictures to refer to or a video like this to watch. So you can see there that the thicker sort of power cables are actually outside of that clip, and it's all of the smaller cables that are inside of that clip. Okay, so I've just brought you in for a closer look to see that from a slightly different angle, and you can now clearly see this plastic clip here. And you can see the cables that are outside of it. You can see all of the cable ties that hold it. You shouldn't need to actually cut any of these cable ties. For me, what I found is that you will need to remove this clip to give you a bit more breathing space. And what I actually like to do is desolder the power lines to where the glass fuses go, so that I can actually pull this back and remove it from the whole sort of circuitry whilst we do the maintenance on the PCB. And I'll show you that coming up. But for now, we'll try and get this clip out. I don't know if I'm going to be able to do it with the camera in the way, but there we go. Hopefully you saw that. You just push and squeeze upwards. And I believe you need to actually do that on both sides to successfully get that out. So I'll rearrange the transformer and do that. Okay, so now we're looking at the other side. And again, I'm just going to get the flat blade of a screwdriver in and just try and lift that out if I can. Hopefully it fits. Yeah, there we go. And I'll just pull that out. And that's what that one looks like. And I'll put that in my parts bag. Okay, so you're going to have to excuse the slightly strange camera angle. It's the only way to really get to show you what I wanted to show you before we move on. There is a thermal sensor. There's probably a more technical name for it, but there's a sensor that checks to see what temperature the heatsink is at, because the heatsink is metal, of course. It goes all the way around the amplifier, and you'll notice that the transistors are actually heat sinked onto them, or using heat thermal paste, to connect to them. But the sensor is really hidden. It's not obvious if you don't know to look for it. It's there. And there's a little screw behind the front door that appears to do not a lot if you don't really look for it. And it's just holding this little plastic bracket, which is part of the back plate of the door. And it's just using that to hold that sensor tight to the heatsink. And you can just possibly make out, let me just see if I can get there, just make out the two legs. There you go. Two legs of the sensor soldered into the board. And when it comes to reassembly, you must make sure that that sensor is secured through that system back to the heatsink, because what you don't want is some sort of thermal issue and that sensor to not trigger and shut the amplifier down, because I believe that's what it's there for. So just remember that when it comes to reassembly, and I'll mention it when we come to reassembly. Other than that, I'll just see if I can just now move the view to be a bit more of the PCB, hopefully. Yeah, there we go. So you can see we actually have 6 main transistors. We have 3 black ones along the bottom, 1, 2, 3, and 3 green ones along the top, and that's the same on the Penta 1 and the Penta 2, and it's the same part numbers. Now on the Penta 1s that I rebuilt, it transpired that actually one of the green ones had failed, and I've got them in a bag here, so I'll show you that when we get to that stage. But for now, we need to disconnect that ribbon, which just pulls away. We need to disconnect that one there, which just pulls away. And I believe that is it. So I will just do that now and be back with you in a moment. So sorry, we're just quickly back because there's a third connector that you need to disconnect, which is this large one here, which appears to be power cables, I would presume, which is the white, blue and orange. And all of these connectors just pull away from the board. So I'll just pull that one away now and be back with you momentarily. Okay, so we're now at the stage where we want to actually remove the front door. The easiest thing is to, if possible, get the door completely removed before we proceed. There's a few things you need to do that. You need to obviously get to these 2 screws you can see here on the base, but you'll see the door is actually in the way. We'll be able to get to those in a moment. And there's similarly 2 screws in the top corner, or corners. And then of course there's this ribbon here, which like I say is new to me, I haven't seen that before. And there's this ribbon here, which is on the Penta 1. And you have to be very careful with this. Anybody that works in IT will know this, but try and pull them out square. Try and wiggle them very gently and just ease them back and forth until they come off. Now this one I've just tried to remove and it does just pull straight out towards us. And this one will pull out upwards, but you won't be able to do that until the door is released. Okay, so now I'm just going to show you quickly that cable coming out. That one you can see gentle wiggle, and it will just pull off square. There it goes. And you can see, yeah, you can see that the pins are not bent in any way. I managed to get that one off nicely, which is good. And now what we need to do is release the door. So let me just spin the amp round and I will show you that. Okay, so I've just repositioned the camera and now we are going to try and remove this door. Now, there's some interesting parts to this. You may find your latch is broke, and if your latch is broke, I'll show you how you get to that in a moment. But for now, what you will need to do is pop the door open, and what you may notice is these bands seem to ride on the inner edges. So you need to compress the door ever so slightly and then push these down and also out, and you'll see that. There you go, that's it down and then out. Same with that one, and usually I try to do one at a time, so we'll try and do the top one first if we can. Yeah, there we go, that's it. Down and then out. And then down, there you go. And you have to be very careful with that because these can just snap off of the door quite easily. And you can see that's the door lifting up. There's a spring, which is how the release mechanism works. That can just pull out, that could go in the parts bag. And then I tend to not push the door all the way back because I don't want to fatigue the ribbon. But you can see a few things have appeared to us now. We can now get to these top screws. Depending on which position the door is at, it will make accessing the bottom screws somewhat easier. You can see the middle screw, which is what I was referring to when it comes to that thermal sensor. And you can see this latch. And this latch I think you can either get something under the front edge of that and lever that up, or there potentially is a hole on the back of this plate. I'll have a look in a moment when we remove that. Once you're at this stage, I spin the amp round and then try and release the door from this plate here. So let me just spin that round and show you how I do that. Okay, so hopefully you can now see how the door actuates. There's just a hole in the actual side of the door, and there's almost a peg moulding on that back plate there. And what I tend to do is just try and get a flat blade screwdriver between them. You just want to ease it off. Just a little bit if we can. And you do that on both sides. Okay, so I just had a little play around there, and I've just reminded myself how I did this. So this backplate moulding, these parts, there's a score. So this is quite flexible, but obviously also quite brittle, so just bear with it. But if you get your flat head in here, you can just create that gap and the door will pop, just like that. And you don't want to pull away, you want to leave it like that and do the same on the top. If I can get it. Try and pull it away. There we go. There we go. Okay. There we go. Okay, so pulling away was actually the trick there. Okay, so you lift the door up ever so gently. That will now expose this ribbon connector, but I probably wouldn't tackle it just yet. Now I will remove the screws that are holding that back plate to the amplifier. And just the same Phillips head screwdriver is doing this. These are smaller screws, they're machine screws this time rather than self-running screws, so you can differentiate this from the other screws. And the screw that holds the thermal sensor on, I believe, is a different length, so again it's quite easy to differentiate that one from the rest of the crowd. Sorry, my hand is in the way here, but just undoing the screws on the top. Ones that I showed you earlier. And the last one now. Just get that one out, put that one somewhere safe. And then, yeah, actually on this amplifier, the centre screw is silver rather than black. So it's really easy to see that. And that plate won't come loose until that one's been loosened as well. So you just want to back that one all the way off. Take him out. And now you can see that plate is completely loose. Now it needs to slide up slightly to stop fouling on that sensor. And then, there we go, you can see the whole plate is now loose. The only thing that's holding this on is actually the ribbon cable. And now we need to decide what the best way is to remove that ribbon cable. Okay, so here we are back looking at the inside of the amplifier, and you can now see this door is completely loose. And you can actually now see that thermal sensor exposed. You can just see it there. You can just see there's a tiny bit of thermal compound there, and it's actually still, yeah, it's still quite fluid, which is nice to see. And that's just to help with the thermal transfer to the sensor. And we'll clean that up and put some new paste actually back in there to make that possible. Now, I've looked at this, and I think the best thing we can do is actually try and back that connector off from the inside. And I'm going to do that with this flat bladed screwdriver. I'm just going to push gently there and sort of in the middle, and then a bit more there. And I'm going to support the back of the ribbon over here with my hand and just trying to ease it off. And it's a very slow process because it's not moved in a long time. And I won't be able to do it on camera because I need to see what I'm doing, but it should ease off. and I'll show you what that connector looks like once that's done. Okay, yeah, so we're back, and as you can see the cable did ease off, and once that's eased off you can quite literally just lift the door away, and you can also lift away the plate. And yes, as I suggested, I think you can get to the back of that latch on the back of that plate there, and we'll have a closer look at that in a second. Okay, so here we go. You can see we've now got the door, and we've got the backing plate for the door, and you can see how that hinge mechanism works there. You can see what I meant with the score being there. The door is pretty simplistic. You've got your buttons on the top, you've got all your sliders. Of course they're different depending on what generation of Penta you have. The back, it looks pretty identical with the exception of that additional connector there. It would be interesting to know what that gives the Penta 2 over the Penta 1. If anybody knows what that is, that would be interesting to know. In regards to the backing plate, you can see what I mean now about the bit that holds the sensor. You can see there is a sort of circular bevel to it. And you can see the latch there, the latch mechanism. And what I'm actually going to do, I'm just going to hold the top. You can see mine's fine, but I'm just going to hold it gently and just push on the bottom there. And there you go. And that's how that latch comes out. No tools required for that. And you can just replace that with one from Martin. He does it on his site there. I ordered one for the Penta 1s that I did. And that latch went in perfectly fine and fixed that issue of the door not shutting. And you can see they just click back in with a nice confident click. Okay, so the next job would normally be to start working on the electrolytics. Now what you can do at this stage is you would remove this isolating cardboard piece, and you would remove the screws for the support that holds the connectors on, and that would give you access to the back of the board where the electrolytics are soldered to, and you'll be able to desolder them. I have successfully removed all of the capacitors and replaced them in that way. It's not my preferred way because it can be fiddly, but it is definitely possible. One thing to note is that when you do remove these bars, which I'll show later in the video, but when you do, sometimes, especially on the Mark 1 or the Penta 1, you have to actually desolder the speaker connections to the PCB to get clearance to move this enough to get to the capacitors. So just bear that in mind. Take lots of photos and keep a record of where everything went. But that's not the way I'm going to do it. So the way I like to do it now, as I said earlier in the video, is I like to desolder the power cables to the main transformer, and I like to pull those out. So just keep a record of where those cables are and what orientation they go in, because you don't want to twist them. You want to make sure they come through nice. You want to make sure you've got enough slack when it comes to reassembly. And you can see that they just go down the side of the tab for that screw there, and they just fit between a groove in the PCB as well. So just bear that in mind. Looking at this, you'll need some quite high temperature to get those to desolder, and just use a little bit of solder, a little bit of flux, and ease those out, and then we'll clear those tabs up with a desoldering station, and they'll be ready for reassembly. So I'll just get all the bits I need ready for that, and I'll show you that next. Okay, so we've got the soldering iron on, and that's heated up nicely. This is a brand new soldering iron to me. I've literally used it once to desolder a capacitor the other day. It's the T12 soldering station, which is highly recommended online, so we will see how this goes. In terms of solder, I always like to use at 60/40. I just prefer leaded solder over lead-free. It's just how I've always been. And this particular stuff is 0.38 mil, and you can see it's very fine, and it's perfect for fine soldering in low temperature points. And I find you can really control it well and get it where you need to be. So I've ripped off a little bit of solder here, and I've got a flux pen as well. It's only a cheap one off of Amazon, but I was always told with everything, a little bit of flux goes a long way. So I will just pop a little bit of flux on those. We're going to add a little bit of solder. If I can get the iron out of the holder there. The tip I'm using is a BC2. Normally I just use a pencil tip, but I thought I would try this to be a little bit different. Just going to try and heat that up. I'm not sure if there's going to be enough temperature in the iron to do this. We may need a little bit more temperature, but oh no, that looks good. Did it heat the other side, I wonder? Okay, so I need to switch hands here because we need to try and pull this cable out whilst, or at least try and get it in the right direction. Yeah. I'm just going to stop the camera and just try and desolder this, but essentially what we need to do is just heat that solder up, try and get that cable out. Now, if we can do it like this, great. If not, I might need to get the desoldering station on to now remove some solder, and hopefully we can get that cable out. But I'm going to try and heat the back end of that cable there and just try and straighten that one out, and then it should pull out. So I'll try that and come back to you. Okay, so I just knocked that temperature up a touch there. I went up to 315 degrees. I just have a bit of extra heat there. And yeah, I was right. I just touched the back of the cable, managed to eke him around a little bit, you know, wet up that solder and get that one out. That's come out quite well. And then I'll just use a little bit of flux in the desoldering station to tidy that up. Not that it's extremely necessary, but I'll just tidy that up, ready for reassembly. I'm going to do the same thing with the remaining two cables, and we'll get those disconnected, and then I'll come back to you in a moment. Just a quick note, those cables were quite simple to get out in the end. They come out quite nicely, so I can reuse them without having to cut them or anything like that. The black wire is a bit of a pain because you've got the neutral wire going to it because they're sort of wrapped around each other, so just be careful, just take your time. Try not to end up ripping or having to cut the wire, because otherwise you have to strip a bit of sheathing off and you'll end up with less slack. So try not to end up in a position where you have to do that. Solder, flux, take your time. Use pliers if you need to hold the cables, to pull them away if they're too hot for you. Other than that, back in a second. Okay, so yeah, as suggested, that was a little bit more fiddly. You can see the neutral there. I've just had to sort of hit it with a solder iron to spread those strands back a little bit. Looks messy, but the cable's not damaged in any way. And I'll tidy that up when it comes to reassembly. But the good news is that all cables came off successfully. No damage, good to go. So what we can do now is we will now take the power cable and move that out of the way. And that will now enable us to think about trying to move those cables out. Yeah, they should pull out. I'll have to do it off camera, I'm afraid, so bear with me. Okay, yeah, so they successfully pulled out now. And you can see by actually desoldering and pulling them out, you've been able to pull the transformer and all of the loom right over to the side of the casing. And now, if you didn't want to do the transistors, I believe, well, I know that you can safely now desolder all of those capacitors, clean up that board, and get the job done. So like I say, at this stage, get in there, desolder them one by one, ideally, make note of their orientation, and replace them. But now I will move over to removing the side panels. And at this stage, once the side panels are removed, you can then declip and de-heatsink the transistors, and then we can actually unscrew and remove the PCB in its entirety and separate it from the board. Okay, so now we have the panels labelled up, as discussed previously, and now we need to remove them. Now, these panels are quote unquote slides to remove, but they obviously haven't moved in 20 years or so. So you'll notice I'm wearing gloves. This is so that it protects my palm. I'll put a picture up on the screen in a second. But essentially, the first time I did this, I didn't wear gloves. And I pushed and pushed on this panel, and it suddenly moved. And let's just say that these heatsink fins are very sharp. So I don't want that again. Now, I think some of these panels are directional. I think most of them are supposed to probably move maybe upwards, but one of them moves downwards. But we'll sort of get a feel for that hopefully now. So I'm going to try and pull this one towards me here. Doesn't seem to be going, so I'll try the other way. Okay, so I just referred to my photos from when I did the Penta ones, and it looks like this one pushed up and the bottom one pushed up, and then these probably pushed down. And I seem to remember that this correlated to where these little sort of little pins are. You notice they're there and there, but they're not there and there. So I think that these push up, these push down. I'll give it another go now, we'll see. Let's see if perhaps it will move. Okay, so if like me, you just cannot get these side panels off, which doesn't seem to be happening right now, you can probably see that you've got the clip to the transistor bodies in there. Could be possible to get them out without taking the sides off. I'd like to say to take the sides off to fully clean the heatsink and what have you, but if that's not possible, we'll have to try and do it this way. So let's see if I can just get a flat blade screwdriver in there and just pop those out. Yep. And that's just reminded me that you're better off trying to hold the back of these just so they don't go ping and fly across the room. Let's just see if I can get this one. From memory, it can hurt if you ping it against yourself, but we'll give it a go. Okay, so I've managed to get 6 clips out with the flat bladed screwdriver, but there is actually a 7th one. There's a smaller sort of transistor type component down here, and that's a 7th clip. And you may also notice that there is something which is attached to the side of the amplifier body, and it's a little bunch of wires that goes to a small PCB, and there's actually a small screw in the side of the body which I'll show in a moment. But for now, we need to just try and pop that last clip out. There we go. So that's the 7th clip out. And now what we'll do, we'll just rotate the assembly, and you'll see, there we go. Hopefully, yeah, you'll see a small cross-headed screwdriver head, and it actually goes to a small nut on the back. See that small little nut there. And for disassembly, I found the best way to do it was with just a pair of pliers, just to loosen that one off, and then a cross-headed screwdriver in the front. For reassembly, it can be a bit more awkward, but I'll just try and get myself set up to do that, and I'll be back with you in a moment. Because I believe that the screw is actually threaded into the body, so you want to try and loosen that nut first. Now I'll see if I've got the right bit to remove that. Let me just try. There we go, I've got a little kit here. See if I can find what size nut that is. Yep, that did it. So using this little kit here, I'll show you this in a moment. I've just managed to use a flexi bit and just back that little nut off. You can see it's just fell in the bottom there. I'll get that out in a second. But that's just a little mobile phone kit I've got, just with some little bits and what have you. So that seemed to do the job. And what you'll find is that board has actually just disconnected itself there, and you can see it's covered in thermal compound. So you need to clean that up and re-add that, and it's key to get it on the little transistor there as well. So with that removed, we can now actually pull the whole power supply board away, and this can now be put away safely until we go to do the big capacitors on the back towards the end of this repair. So I'll just put this away. So now we have the much lighter body to deal with. You can see that we've got the raw PCB now. We've got the clips out of the way, which will allow us to pull that board out. That clip, I'll probably just get that out off camera in a second. A little nut just fell down the bottom there, so I'll just put that, and I'll put that in my parts bag in a second. And now what we need to do is we will need to loosen these screws towards the end of this section. But what we'll do first is we will actually just try and very, very gently loosen these transistors from the heatsink. And the reason I say very, very gently is you can see on the small one, there's actually what some people call a piece of glass. Obviously it's a piece of plastic, but there's an isolator, and it's semi-rigid, and it's sort of laminated clear plastic. And if you try and forcefully remove it, you can delaminate it and end up with brittle, smaller parts of it. So what you want to try and do is leave that on the heatsink, get your transistors loosened so we can pull the PCB out in one section, and then we will soak this in hot water and gently get those off later on in the video. So let me just try and loosen some of these off now. I'll try with a flat head, but maybe that we actually try and add some liquid to this to loosen them. But that one there looks to be fine. Let's just have another look at the next one there. Yeah, that one appears to be loosening off okay. That one's already loose, that's great. The small one, yeah, I've just managed to loosen that one. There's actually another smaller one there. Let's just whip my way around, just breaking the join on them. Okay, so that should be fine. So I'll just try and wrap that cable in the middle. There we go. Just pop that down. And I should be able to just remove the 4 silver screws on the base there. And like I say, don't rush this. Just try apply a bit of progressive pressure to get these to remove. it should just lift off. There we go. So now we have the PCB, and you can see one of the pieces of glass has decided to stay on it, which is fine. Just be careful with it. And you can see the rest of them have actually stayed in there, so we'll remove those later. And now you can see for the first time that little thermal sensor there, and you can just see the compound on there. So let me just put this board down and we'll get a closer look at it. Okay, so now you can see we've got our first sort of closer look at the board when it's not in the body in the heatsink. And you can see there's a few things here to mention. We've got, like I say, the 3 big transistors on this side we're going to replace, the 3 big transistors on that side. But this section of the video is going to be all about the electrolytic capacitors. Now we've got the 2 at the back, we've got the 3 here, the big one there, the 2 smaller ones there, we've got a couple over here, one there, and that's it. That's what we're looking at in this section. After that we will replace the trim pots, and I will be giving the board a clean to remove all of the dust, and we'll proceed to that shortly. Okay, so I just want to take a moment out of the video just to show you the kits that we're going to be fitting, the capacitor kits. So this is the parts from beopartsshop.com. This is from Martin. And yeah, great guy, great kits, and I just wanted to show you the box so you knew what you would get, and go through it with you. So I've opened it, but I haven't actually opened the kits. So they're well packaged. They're all in bubble wrap and then some foam for packaging. And then the kits that I bought, what have we got? We've got the, is that the crossover kit? I believe that's the crossover kit. We've got the the transformer capacitors, which are just monsters, and these are supposedly custom made for Beopart Shop, and yeah, never fitted them before, but we'll see how that goes. And then the bit that I am familiar, oh, there's some fuses, just some extra glass fuses there, just in case I hit problems. And then the last kit, and the main kit that we need to worry about at the moment, is this one. Now I'm deliberately not going to show the paperwork, because I don't want to tread on toes. You know, they've put a lot of effort into building these kits, so I'm going to show what's in it, but I'm not going to ruin it, shall we say, because I don't want to have people, you know, him lose business through me showing the secrets of the paperwork or anything like that. Just have a quick look myself. Yeah, it's the same paperwork as I got in the last kit, and it just shows you a pictorial diagram of what capacitors go where and what have you. So we've got the new OPAMPs, 1 per speaker, and these come with a little socket, which is nice. So if you need to remove it, or if you wanted to put the old one back in, if you didn't like it, you don't have to desolder it again. You can just pop it in the socket, so that's quite nice. Some of these capacitors have the screens, so, you know, depending on if you use the screens, you may not need them, you may not get to them. That's mainly all of the axial ones. And then these are the capacitors needed for the speakers themselves. There's a couple of spares in here. You'll find not all of these are used. You've got the trim pots as well there. Now you need to be careful. You need to make sure you get them the right way round. And unlike the ones that are actually on the board, one minor negative I would say is it doesn't say on them their values. Not that I can see anyway. Let me just check the other one. yeah, I can't see any way of seeing what their actual value is. So, you know, you just use a multimeter, and we'll go through that anyway. Use a multimeter to work out which one is which. Set them to approximately the value that your original trim pots were at, if you can, or set them bang in the middle, and that will be a good place for moving forward. So yeah, that's what comes in the kit. I'll pop that back in the bag now, and we'll proceed with the video. Okay, so for those of you playing at home, we're going to start with the top 1, 2, 3, 4, 5 capacitors up there. Those are capacitors, bear with me, 18 to 22. I'm going to start with those because they seem to be the easiest to get to on the back of the board. And in order to desolder these capacitors, I'm going to actually use a desoldering gun or desoldering station. I really wish I would have picked one of these up years ago. I don't know why I didn't, but I didn't. So I picked up the Duratool, which is a cheap and cheerful device. I'm just going to fire that up now. I'm just going to bring that up to, bear with me, I'm going to bring that up to 300 degrees. So we'll just wait for that to come up to temperature. And what we'll do is we'll just use a little bit of liquid flux, which is the no clean flux, so to say. It does seem to be that way. I do like to clean anyway, but we'll just put a little bit of flux on the pins for these capacitors, a little bit of solder, and go from there. So yeah, see you shortly. Okay, so the desoldering station is now at temperature. Sorry about the noise, I know it's a little bit noisy. We'll just put a little bit of flux onto these capacitors. 22 as well, 18. And we'll just make a start on this. I mean, this tool is literally brilliant. You just pop it on, little wiggle. It's important to keep the trigger pulled after you remove it, otherwise the gun will clog. And just do that again. Straight over the pin, little wiggle, and release. And if you're lucky, this time it didn't happen on the first go, but there you go. And we've just removed the capacitor perfectly. That one, other than a possibly, oh, it's just dust. That one looks okay. We'll test that one in a moment. So that was C19, I believe, there. So we'll just move on to 21. And there you go, again that one pulled straight out. Okay, so we've just desoldered those two capacitors there. And just having a quick look at them, they are 25 volt, 33 microfarad, 85 degrees. Yep, they're both identical, which would make sense. And just out of interest, I'm just going to use a multifunction tester here, just to see, and I'll do this on all of the capacitors, just to see how in or out of spec they actually are. And when you buy this little kit, actually, you've got the little tester there, you've got a little bag of bits, comes with these handy little tester leads, some little instructions. If you have a look at the little instructions, it will tell you. And it says to test a capacitor, it's pins 1 and 2. So we'll just go for 1 and 2 there. Sorry, not quite in camera there, just move it a little bit. And these are quite inexpensive, you can get these on Banggood or eBay, I believe, and things like that. Just pop the little bits back in the bag. and it just uses a cheap and cheerful hooking mechanism for the leg. I don't believe is important on polarity. My red lead seems to be a little bit broke, always has been, just cheap and cheerful as I say. So we'll just pop that on there and we'll just fire that up. We'll just see what we've got here. It's saying testing. And there we go, capacitor, and it's saying 33 microfarads, which is what it is meant to be, right? Yes. So 33.9, so just over, but that sounds to me like that one was good. So it's always good to see if a capacitor has or hasn't failed. Ideally, if you can catch it all before they fell, I mean, brilliant, you know, there's been no damage. Let's just have a little look at this one. Testing again there. .7, so a little bit less than its twin, but basically the same. So sounds to me like those capacitors were good. Looking at them, doesn't look like they've bulged in any way, not on the bottom or the top. We'll flip the board over and have a quick look, see if there was any leakage at all. No, I can just see fluid from the flux, so it looks like I was lucky on that part, and those capacitors were probably still okay for a little bit longer. So we'll fire up the desoldering station and we'll go ahead and do the next 3 capacitors, and I'll be back with you shortly. Okay, so I'm just waiting for the desoldering station to come up to temperature now, and these pins are quite close to the cables, so I'm just gonna try and push them back just a little bit, just push them out of the way, because the last thing we want to do is scorch those cables. I'm just going to add a little bit of flux again, and we'll just have a quick look, make sure the gun looks clear. Sounds fine. They do come with these clearing rods, and it's best practice to just pop them through after every couple of capacitors, because I have had this block a few times through not doing that, and it's really annoying, so just bear that in mind. So let's have another look, see what we can do here. So I'm just going to go for this end one, little wiggle. I think that one, either the rod just snapped there or the capacitor fell down. Looks like it fell down. Yeah, it just fell down. So that's that one. I think that just shows the power of that desoldering station, that the capacitors literally just drop out. So you see here, yeah, dropped out, yeah, dropped out. So just turn that off again, and we'll just have a little look and test these. Now, yeah, this one looks a little bit bulgy on the bottom. That one looks okay. That one maybe has a bit of electrolyte there, maybe, but there's of course a possibility that somebody's been in here before. But let's have a look at this bulging one. See what this one tests out at. It should be 470 microfarads. So let's see what that comes in at. .429. So yeah, I would say that's out of spec. I don't know what the tolerances are officially, of course, but that sounds a little bit out of spec. So that one was past its sell-by date, so that's it's a good job we're doing this. Let's have a little look at the other ones here. This one is supposed to be 220 microfarads. Wow, that one's coming at 204 there. So that's quite out of spec. And this isn't surprising. I mean, this is what you would expect from something of this age, I suppose. And this one is supposed to be 100. This is where the oddity comes in, that some have 220 on both and some don't. Oh, that's interesting. Maybe it is polarity sensitive on the legs. It's not how often I use this, so you just try that again. Nope, that one is showing as a resistor, which is somewhat interesting. So I wonder if I get a multimeter. Just put it back onto continuity. We'll just see. Let's see what this is doing. Just have to do this just out of view of camera. Hang on, let me see if I can just bring it over here. Ooh. Just put that on the bottom there. So that, to me, let's put it on the resistance. Wow. 0.1 on the 200 ohm scale. That says to me that capacitor has a direct short then. Let's have a look at the, that could be why my fuse is blowing. That could be my problem. So let's have a look. See what the bottom side of that board looks like. Oh wow, was that C22? I don't know if you guys can see that. Can you see the, hang on. Clearly electrolytic leakage there on C22. Looking at my notes, no, 22 was the 470. Interesting. So the 100 was in 20, which doesn't really show any sign of leakage. So kind of interesting how that capacitor is clearly failed, but not exploded. Interesting. Okay. So that's the first couple of capacitors removed there. So what I will do is obviously that that electrolyte there needs to be cleared off. So we'll just use some isopropyl alcohol and some cotton buds just to clear that part of the board up. And we'll just do this in sections. So again, I'll put the links in the description, but this was just straight off of Amazon. I've used it quite well. It seems to have no issues, and I just used that and some run-of-the-mill cotton buds. So let's just have a quick go at cleaning that up now. And the beauty with the isopropyl alcohol, if I can get it open, of course, is that it evaporates. So what I like to do is just get my cotton buds covered in alcohol, just wipe, and you can use cotton buds, you can use maybe soft chards toothbrushes, or you can also use ESR resistant brushes, which I have some of those here as well, and I'll use those to go over the majority of the board. But you can see there there's quite a bit of dirt which is coming up off of that board. I just like to use the cotton bud and alcohol just to get up the basic dirt that's going to be there. And then after that I would come in with a brush. Just come in with the brush. Obviously this is going to be a little bit OTT for this section of board, but we can go over the whole of the board like this eventually. And just try and get all the dust off around the legs. Just be careful, you don't want to damage any components. But, you know, that's cleaning up the board quite nice. So what we can do now is just let that dry out, and we'll switch to the soldering iron and just pop the new capacitors back in. So be with you in a second. Okay, so we've desoldered the capacitors at the top of the board there. And I just wanted to take a moment just to whip out the microscope and just show you just how clean that desoldering is. So I will be switching to this, of course, on the main screen now. But hopefully you can see just how blemish free that desoldering process is. And it's just really great because when you read into it, the silk screen on these PCBs isn't particularly great, especially at the age it's at. And if for whatever reason you pushed the component from the other side, perhaps cut the legs, whatever, you can delaminate the traces very, very easily. On the Penta 1s, unfortunately, when I went to remove one of the larger transistors, that's what happened. It delaminated one of the traces. I was able to fix it, just kind of make a repair, but it does happen. So it was one of these. It wasn't the trace so much, it was more the pad. So when it come to which one is it under the, yeah, there you go. When it comes to this part of the pad here sort of thing, that's what actually delaminated. So I had to just use a resistor leg just to bridge it back, and yeah, that fixed it fine. So, you know, options. But whilst we're here, let's have a little look at this soldering. Doesn't look too bad actually. I expected to maybe see some large cracking, perhaps, because they do take a lot of heat. So I did wonder if perhaps there would be some cracking. Whatever that is there, that looks to be an interesting solder joint. But yeah, overall they don't look too bad. Let's have a look at this one. Yeah, they don't look too bad. And I'll inspect my soldering when we redo this and show you what that looks like. Okay, so I just double checked some pictures that I took before I removed those capacitors a moment ago. And it looks like the polarity on the silk screen on the board on mine is correct, which is always nice to see. So the new capacitors are slightly smaller than the old ones. So if we start with the outer capacitors, the 33 microfarad, you can see that the older ones were slightly bigger. It's a similar principle to the older ones actually. If you look, you should be able to see that the legs were bent out slightly. So I've just used the long nose pliers there. And I've just done a similar thing with this one. Just bent the legs out ever so slightly, just to stop too much fatigue perhaps on the body, who knows. So bent them out a little bit and that just drops in. And that looks quite nice in there, so I'll just do the same thing with this other one. I'm just using the long nose pliers. I'm just coming out from the body a little bit, trying to keep that leg straight, bending it out a little bit, and then bending it back in. And I'll just do the same thing there. With these, the negative is denoted on the side of the capacitor, and the negative is always the shortest of the two legs, just in case you didn't know. And that one is just dropping in there nicely. Yep. And you just want to make sure when you do solder them in, try to stop it from touching anything else, just so there's no sort of unwanted heat transfer. Make sure that there's a nice airflow around the components. So my soldering iron is on and up to temperature. And what you do is when you flip the board over, just bend the legs out slightly. Just like that. And that'll stop them falling out when you go to solder them back in. So, just checking my gapping. Yep, I'm happy with that. So I'll just use a little bit of flux. Just get myself some solder. Just re-tin my tip. Yep, happy with that. And when it comes to soldering, you want to apply heat to one side and the solder to the other side so that you get a good joint. So I'm going to go heat on the left. I'm touching the leg and the pad, and I'll bring the solder in, feed it in, and then pull away, and that looks good. Let's do that with the next one. Quite completed it, so I'll just apply it to the other side. Yep, that looks good. Yeah. Once you're happy with it, get yourself a decent set of side cutters, and these are the flush sort, a bit dusty, but they cut nice and tight. Obviously don't cut too tight that you damage the actual solder joint. You just want to cut and remove those legs, and ideally probably hold them so it doesn't take off into outer space. And keep those legs because they might come in useful for repairs in the future. So that's the first two capacitors done, and I'll just bring the microscope in quickly just to show what that looks like close up. Yeah, that looks fine. Looks like I've got good adhesion to the pad. And then if we just turn over, just look at the components, and you can see that the capacitors are nice and straight, they're not touching any components next to them. Happy with that. I'm happy to proceed to the next capacitors. So the next capacitors we need to do are C22, C18 and C20. I'm just looking at this. 22 was the 470 microfarad, which is this one here, and the original was 25 volt, and this is 25 volt as well. The difference being the original is 85 degrees C and these are all 105 degrees, so keep this amp on for hours at a time, and it shouldn't matter, you know, it's never going to reach that sort of temperature, or at least you hope not. So so the 470 is 22, so I'll just pop that one into there. Like I say, the silk screening was correct, so that's negative to the left. I'll just give that one a little wiggle down. There he is. 18 was the 220 for me. That may differ for you, of course, so be very careful when you go to do yours. Make sure that you follow whatever is on your amp, not what's in the guide or not what I'm telling you, because that's what matters. So these are the other way around, these are negative to the left. I'll just bend these legs whilst I'm here. And then the last one for me was a 100, which is C20. And again, that could be 100, it could be 220. So just follow whatever is on your amplifier there. Possibly I could stop here. I mean, who knows? It definitely looks like these capacitors had problems. They were out of spec. So you never know. It may just work straight away after this, but then again, the likelihood is they're all out of spec, so we will see. I'll add a bit more flux. And that end one's just not quite sitting on the PCB, so I might reheat that when I get to it, but we will see. So, this first one's a little bit awkward because that bracket's in the way. But after that it should be okay. Might need a little bit more heat on my iron. I'm at 210 at the moment. May just apply just a little bit more heat. Just try and catch the back of that pad if I can. Yeah. Okay, good. So like I said before, just cut these legs off. Try not to cut too close because you may pull the pad up, which is not what you want to do. So just get it as close as you can within reason. Don't have to be the closest the first time, you can always cut more off if you need to. And there we go. I think I'm happy with that. We'll just see what it looks like on the other side. So yeah, happy with that. Capacitor's not quite straight. Like I said, I could if I really wanted to, which I may do. Don't push too hard because you'll pull the pad up, but just go back in and just gently heat that back up and just rock that capacitor back down. Just straighten that up, and there you go. So that's the first 5 capacitors done. So the orange ones are very hard to get to. As I said earlier, you're going to need to move all of this connections out of the way, so that's going to be a bit of a pain. I think the big one over there is a bit of a pig as well, because the bracket's in the way. In fact, the bracket is in the way of every up and coming capacitor. So what we will do is we will move on to how this bracket is removed. So this hopefully I should be able to just pull this out. Yeah. So the isolator card can just pull out gently. Try not to bend it, try not to distort it. It's important, keep it. It's going back later. In order to get this bracketry system off, you'll need to lift it off of its plastic pegs. So there's 4 pegs holding it down. I was just checking there to see if the screws went through the board, which it doesn't, but they do hold it square. So what I would do is I would loosen the screws next. Try not to push down too hard, of course, because you don't want to bend any of the components that are underneath it. So there's 2 small black machine screws here. And then there is a ground lug, which I'm not sure I remember that from the Penta ones. So I'll just loosen that off as well. That screw seems to be holding in for me, so that should be fine. And then to remove these plastic pegs, it's a bit of trial and error. When I did it, I had some slightly different pliers to this, but basically what you want to do is try and squeeze it to the point that the metal will pull up over it. Now, I'm not sure, there we go, yeah. So hopefully you've sort of got that, managed to just squeeze it and then gently push on the metal, and that's come up above it. I found that pretty much get them all to that stage and then you should be able to lift them off. So I'll just try that again on this side, if I can get the right angle. Yeah. So I think this side should, there we go, click, and should put off. There we go. Just to the other side. The key is not to rush, it's not a race. There we go. Okay. So you can't just pull that off because obviously it's still soldered and connected to the board, but what you can do is manipulate it around. Right, there's another screw there actually that I missed. And there was a little serrated washer under that ground lug. So just put that safe over there. And yeah, there you go. It's all now sort of fluid, it's all loose. So you should be able to manipulate this enough to get to what you need. So that bracket can be removed, which is helpful. Hopefully the other side is the same. Yeah. Of course that's all connected. There's a slightly different design to the ones because this whiteboard wasn't there. I'll put a picture up on the screen of what that sort of looked like. It looks a little bit different to this. I don't believe you've got the audio video switch on those earlier amps. I don't believe so anyway. Can't remember now. So let's have a look. So we've got the big capacitor over here, and you'll now notice it's really easy to get to. You've got both the legs there for, I believe that's C31. Like that. Yep. So I'm just going to fire the desoldering station back up and turn the soldering on and off for a little bit. And we'll just wait. Okay, so we just got the soldering station come back up to temperature. So I'm just going to add a bit of flux onto C31. I'm hopeful that this should just fall out. So straight over the pin, a little wiggle. Yeah, he looks to have fallen straight back out. So I'll just turn over it and yep. Looks a little bit crusty on the base of it there. Yeah, a little bit. Doesn't look to have bulged at all, but still a little bit crusty. Let's have a look at the underside of the board. Yeah, he's definitely leaked. Sorry, the handle's in the way there. Let me just move that cable out of the way. Hopefully you can see the reflection of light. Just put the light on there. You can see there's been leakage on that capacitor as well, so that will need to be cleaned off. And we'll do that in a similar way. But whilst we're just try not to let that flap around like that as well. But whilst we're just waiting for that, I'll turn that back off. And we'll just test this capacitor to see how out of tolerance that one is as well. So that should be 100 microfarad. Let's see what that one's saying. It's coming at 95, so it's not. It's probably intolerance, probably, but it has leaked, so it's only a matter of time before it would have been out of tolerance as well. So I will now go ahead and clean that up. So whilst I've got this side of the board up, I will just use a little bit of alcohol and the cotton bud. And I'll just clean the back side of the board. Just get that electrolyte off. And I will just right away slightly. Just go in with the brush. Sorry about the noise outside. Just go in with the brush there. Just try and clean as much of that area as I can whilst that capacitor is out the way. Obviously I'll have another chance once everything's finished, but it's nice to try and get it done when the bigger components are out of the way. Okay, so I've cleaned up the board. Hopefully you can see that the electrolyte that was there is gone. I've cleaned up the back side there as well. So I'm just going to pop that capacitor in. I've just double checked, and again the silk screen is correct, negative side towards the middle of the board there, so that seems to be fine. Just try and tip that over, just bend those legs to get that to hold. Just use a bit more flux, just out of screen there, sorry about that. And I'll just see if I can bring the camera in for a closer angle on this. Okay, so hopefully that's a closer angle for you. So we'll just give that a little bit of flux, just on the flux pen there. Of course, solder does have a bit of flux in it anyway. but I always like to add a little bit more. Just add a bit of clean solder into my soldering iron tip there. And again, like I say, heat one side and try and feed the solder from the other. And that should give you a good joint. And that's another capacitor done. We'll just cut those legs. And there we go. So I think now, looking at the board, what I'll be going for next will be C39 and C27. I'm working my way in from that side of the board. So I'll fire the desoldering station up again. And as I say, this board is normally covering it, but we can just move it ever so slightly aside to get to the pins for 39 there, and similarly with 27, it's just on the cusp of that board. Okay, so that's come up to temperature, so I will just have a go at that one, and again, like I say, over the pin, little wiggle. I don't think that got all of it that time. And that one's removed, and that one, yep, he's out as well. So as before, just quickly test these capacitors just to see where we are with these. Because I think it's interesting to see what part of the amplifier is failing, to see if you get the same problem. So that's coming in at 99.3, which is supposed to be, is it supposed to be 100? Yeah. So that looked good, and then this one's supposed to be 447. So a quick look at this one. $444. So that must be a 470. Let me just double check. It's hard to see. I'll just show you. Fortunately, the number's caught right on the ridge of the moulding of the capacitor there. Oh, sorry, they've measured it in nanofarads. Okay. So that's relatively close. That's coming in at 0.8 0.44 rather than 0.47. Okay, so as with before, we'll just double check. It looks like there's not really been a huge amount of leakage on these two, possibly a little bit on 27 there. So we'll just go in with the alcohol, just clean up that part of the board, and I'll follow up with the brush. And I'm not worried too much about getting near the transistors because I know I'll be cleaning that part of the board later on. So if you're not doing them, then of course feel free to go in and clean that part of the board. Okay, so in interest of trying to cut down an already lengthy video, I've just soldered in C39. I can confirm that on mine the silk screen is the right way round, so that's good. It's negative towards the outside of the board, so that's gone in. I've cut the legs, that's fine. But I just thought I would do something which might interest people. So the C27 was the 0.47 or the 470 nanofarads. I'm just going to put the old one back on the tester again if I can get the leads to go around the legs. So that should be 470 nanofarads, and it's actually coming out at 444. Obviously it's quite a small measurement, so it'd be interesting to see what the new one is. So I've just got the brand new capacitor here from the kit. Just going to test that. And that's coming in pretty much bang on. 470.9, so that looks really good. So fingers crossed, fitting these capacitors is gonna save this amplifier. So similar principle with all the other ones. We'll just use the pliers, bend the legs out, pop it in, solder it, cut the legs, and move on to the next bit. So I'll see you in a second. Okay, so C27 and 39 are now done, and I'm now going to move on to the small green ones, the black one, the orange one, and IC2, which is the OPAMP, which is directly below it. Let me find something. So that there, that chip and the socket is going to be easiest to do when that capacitor is out. So we'll take these four capacitors out, take this out, clean this part of the board, and then we'll pop the socket and the chip in first, and then we'll move back onto the capacitors. So I will fire up the desoldering station and we'll go from there. Okay, so the desoldering station is up to temperature, and I've looked at this, and obviously we want to move the next set of capacitors. Now, unlike the Penta 1, it actually looks like this is easier to service. This board, you can just flip it up. So we may be lucky here and not actually have to desolder anything. Like I say, on the Penta 1, you may find you have to desolder some of those speaker connections. So we'll just flip that up and back and just rest that if we can, if it needs to. And I'll come in with the flux, and it looks like we're going for C14 and C25. So we'll get rid of those first. If we've been lucky, we'll be able to just push those out. Looks like it might just need a bit more persuasion. do is we'll just tip the board up, just have a little look. And yeah, 1, 2, straight out. So we'll just have a quick look, just see what those would test out as. So we have a 10 UF, I think, are they both 10 UF? Yeah. Yeah, just under, so that was not too bad. No sign of bulging or anything. Yeah, just under. So, I mean, if anything, it just says that for the age, they did a good job with the brands of capacitors they picked. You know, they didn't all fail. So now we need to move on to C5, which is just above IC2. So we'll just do C5 there, and then we'll move on to the IC. When it comes to the IC, you can see it says IC2 there, and we'll just try and liberally add a nice amount of flux on the pins. We'll just run through those. I like to try and alternate, just to stop the heat being in one part of the chip. And again, if we're lucky, that chip should, yeah, just push out. That looks good. So we'll just have a little look from the other side. And yeah, it looks like that chip is ready to come out. These pliers are a little bit bulky for this job. Let's get that capacitor out of the way first. Nope, that's not quite loose enough. And there's the chip. All the legs are perfect, and you could reuse that chip, like I say, in the socket if you so wished. Let's just have a little look at this capacitor, see what's going on here. Yeah, it just feels a little bit tight on one of the legs. Actually, it looks like it's just because the legs are bent. It's just holding in the board by the fact that the legs are catching the board itself there. Yeah. Just for consistency, we'll just quickly test that one. That should be 2.2. Just over actually. At 2375 nanofarads, that one. So we'll just have a little look at the other side of the board there, and possibly a little bit of electrolyte on 25 and 14 there. and C5 possibly. Could just be a little bit of flux, but nothing too bad to worry about. And then I'm just trying to work out what capacitor that is. I think it's 29, which, yeah, I think it's there, because the odd thing I remember from the Penta 1, the odd thing is that the pins and the pads don't, it's two set. If you notice, there's some fully tinned underneath it, so I believe that's that. So we'll just add a little bit of flux. If you think I've got bad hand-eye coordination, it's not that. I've just got bad nerves and shake. So, but there we go. So that's that one come out. We'll check that one again in a moment. Again, not too bad under there, but we'll clean all that part of the board up and get that sorted in a second. We'll just quickly test this one, which should be .470 by 6.3 volts or 6.3 volts. Let's have a look. Yeah, he's coming just under 4.43 rather than 470. So I'll, at the end of this, I'll put a spreadsheet up and say which capacitors were out of spec, because I think that would be interesting to see. Great. I will get this station turned off, clean up the other side of the board, and we'll discuss fitting the socket. Okay, so in the kit you have this little anti-static bag, and there's a little bit of anti-static foam within it. And on that piece of foam is 2 sockets and 2 amplifier chips. So you can just see that there. And the chips are actually an upgrade. And having listened to the Penta ones with and without them, I can definitely say it's an improvement. I've spoken to other people in the community and they also say it's a good upgrade for the Beocenter 9000. Don't know if it's the same for the 9500, but if it is, that'll be next on my list for my Beocenter. The reason for the socket is just so that, like I say, you can actually swap out the chip if you want to, or if you damage the socket, it's a lot cheaper than damaging the chip. The way the sockets are designed, you've got a little U at the top that symbolises the top. I don't know if you're going to be able to see it, but on the board there as well, you can see you've got the representation of the chip, and you can see pin 1 is the top left hand, and you've got the U symbol on the top of that socket. So what we're going to do is we're just going to drop that in. Now, if you didn't take the board out of the casing, this is actually quite fiddly. I did manage to do it in the end, but it took a few attempts. But for me, this shouldn't be too bad. I might try and just use these pliers. I'm just going to try and drop it in. Oh, there we go. So that's in there nicely. Now, obviously, you've got to solder it from the back, and what you want to do is either hold it in the board with a piece of tape, or hold it with one hand whilst you get one pin started. I think I'll actually try and do it with a piece of tape, just to make it easy. So let me just get a little piece of electrical tape here. I'm just going to put it over the socket, just over a little bit of the board, and that should just hold it. So just turn the PCB over, or rock that second board back, and yeah, I can see the pins, and I can see that socket's looking to be sat quite nice and square. And he's just fallen back down in there, so I'm just gonna try and get a finger under it if I can. There we go. So what I'm going to do is I'm going to just load up my iron with a little bit of solder. Let's do that now. The idea is just to tag the outside pins, or whatever you want to call it, and then solder it in properly. So I'll just get a feel for the piece of tape. I'll just start with this top pin here. Let's try one of the lower pins. There we go. Hopefully that should be enough. If I'm delicate, that should be enough to do what I need to do. So I'll just unravel myself because I was twisted around the lead for the iron. Just start with this top pin here. I'm just going to go down the socket. It's getting a little bit difficult to see with the camera in the way. And my stupid hair in the way. Okay, so that should be the socket soldered in there. Just checking that it's the best soldering I've done. So I'm just going to just go over that again. Add a bit more solder till I'm happy. I'll just bring the microscope in and just check that. I will just clean that off first, just with a little bit of alcohol there. And we'll just see how I did on that. Hopefully I did okay, but we will see. I'll bring this up on screen in a moment. Just trying to find where I am on the board. Yeah, there I am, IC2. Don't think it looks too bad. Perhaps pin 4 could do with a little bit more solder there actually. That bottom pin. It's not the best microscope in the world, but I will just add just a little bit more to that bottom pin. Just recheck that. Yeah, happy with that now. Good. Again, you can see just how clean it removed C5 there. Okay. So now, at this stage, we might as well put the chip in. So I'll just carefully remove this piece of tape. And with this chip, I do actually have, or I did have, Yeah, I do actually have a nice little set of pincers that when you let go they grip. So I like to use these for doing the chips. Actually, this chip, first of all, it's important to mention, if you look at the legs, they're sprayed or splayed out. So you just need to compress them in square. So what you normally do is just pop it on let me find a bit of the bench you can see. Pop it on a bit of the bench and then just push down on it. So I'll just try and show you that. So you just get it and then try not to bend the top pins, of course. Just squeeze it till they're square. Squeeze it. And then what's nice by having the second socket is you can just test fit it on that socket and just see if those legs are going to line up, which that looks good to me. That looks like that's going to go in. And you can see now those legs are nice and flat. So we'll just pick that up with the tweezers. If I can get it on. And bring the board back across. I'll just, there we go, get it lined up. Let go of the tweezers. And just push that home by hand. And there we go. That's the OPAMP changed. As you can see, the top of the board has all been cleaned. I've gone over all of those capacitor holes, and we will now begin to refit the remainder of the capacitors there. Okay, scratch that. It's 9:45 at night. I think it's beer o'clock. So let's get back to it in the morning. See you for now. Okay, good morning. We are back on the bench. Refueled for my bacon sandwich. So good to go. So something I forgot to mention last night is when you're finished with the old chip, the best thing to do is just pop it back on this phone. And then you can put it back in your bag. Obviously I'm not going to use the other chip because I'm not doing the other amp right now. And it just keeps it safe, it stops the legs bending. So pop that back in the bag, put it back in with your caps and you're good to go. So that's that out of the way. I've done a bit of reading last night. I just decided to jot up and compare all the values of the capacitors that we've taken out. Just put them in this bag for now. And it's quite interesting, if the tolerance on them, which I don't know for a fact, but if the tolerance on them which is 5%, which is unlikely, quite a few of them is failed. But if the tolerance was 10% from factory, actually there's only one that's out of spec, and that's the one that failed with a direct short. So that's quite impressive. Quite a few of them were leaking, but my speakers didn't sound bad. They always sounded good to me, so that's quite impressive, considering the age of them, but there we go. So today what we will do is we'll finish up putting these capacitors in. Some of them are going to be slightly different because I believe one of these capacitors is going to be one of the red type. They are bipolar, so they can go either way. And we will see how we get on. So I'll be with you in a second. Okay, so it's the same as before. With these capacitors, if they didn't come with the legs bent out from factory, bend them out with the pliers just to get a bit of distance on them. The only difference is, like I say, this bipolar cap, this is going to go in C5 directly above the IC2, and luckily the leg pitch is exactly correct. So what we'll do is I'll just see if I can just get the right angle to show you. And it literally just pops in. Just see what I'm doing, perhaps. Yep, there you go. Obviously it's on an angle, so it's going to be sat weird at the moment, but it will just sit nice and flat there. So that one will hold by hand when it comes to soldering, and the rest of them we can just do the same principle where we bend the legs out and solder it from the back. So I'm going to do that, clean the board up, and I'll be with you in a second. Okay, so we're back. Those capacitors have been soldered in. I've cut the legs and used a little bit of alcohol to clean the board. Now I'm just using the microscope, you know the drill by now, just to check my solder work. And actually this is quite a good example. I'm just gonna start recording on the microscope now. And one of my soldering attempts, shall we say, at one of the capacitor legs is bad. So what I've done is I've not actually applied enough solder. I imagine it would hold fine, but you can still see some of the through hole. So what I'm probably going to do is I'm just going to add a little bit of flux now. I might just do this under the microscope, and it will just give me, or give you guys an opportunity to see what this looks like close up. So let me just try that now. It's probably going to look a little bit ugly when being done this close, but we will see how this goes. Okay, and in this instance it looks like I didn't need any additional solder. I was able to use the solder on the tip of the iron, and that looks a lot better. So we will just use a little bit of alcohol just to get rid of the flux. Obviously that will evaporate in time, and yeah, I'm pretty happy with that. I think that's the only one I was worried about. Yeah, the chip there, I was happy with all of those originally. There does appear to be a slight divot potentially in pin 1, so I may just come in and quickly reheat that one. There we go. That actually looks like that might need a little bit more solder perhaps. It's hard to judge what it looks like. Actually looks like there's a yeah, somewhat interestingly it looks like there's some dirt come across from the other component there. So there we go, just removed that. Again, clean your work. Yeah, that looks fine now. I'm happy with that. So I'm going to just bring that up to the actual camera, just so you can see that it's not the ugliest work in the world. In fact, I'm quite pleased with that. And hopefully you can see it genuinely is quite hard to differentiate between being OD'd and what I've done. So I'm quite happy with that. So that's those capacitors soldered in. And as you can see, they're all sitting quite nicely. So now we've just got the remaining 2 orange ones there to do. I think we're reaching the end. So bear with me, let me just set that up and we'll continue. Okay, so somewhat annoyingly, I've just gone to record this section twice, and the microscope died, ran out of battery. So I've got them on charge now, but I had a quick look at the footage as well, and it looks like the footage isn't coming out as great as I'd have imagined. So sorry about that, but it is only a cheapy job, so we will see how it goes. But anyway, so the plan of action now is to replace the final two capacitors, which is going to be this pair of capacitors here, which hopefully you can see. I can't see if they're out of shot or not. There we go, two bipolars. So C2 on the board, I'm just going to show that on the microscope now. And you can see that one's not too bad. We should be able to get that one out. What I've had to do is I've had to just hold the cable back with a pair of tweezers, just so that the desoldering station doesn't hopefully clip that cable. But if we come across to C1, which you can just see there, C1 is actually connected to the negative of one of the speaker cables. So what we might find is when we go to heat that up, that cable may either disconnect or it may move. So just bear that in mind and be prepared to move that back to where it needs to be. You may find it's easier to just remove that cable beforehand, and then you know what you're doing when it comes to reassembly. But I'm going to move across to C2, and I'm going to try, and if I can, desolder this one under the scope. I'm not sure if there's going to be room or not. So I'm going to try that. I'm going to try that now. So I'll be back with you in a moment. Okay, so we're back. I'm going to apply a little bit of flux. I've already put some on there, but I'm just going to put a little bit more on there. You just see that coming out there. And let's give this a go, see how we get on. So I think I'm probably going to find this is going to be in the way, which is really annoying. I might be able to just get the end of that one. No, I'm not going to get the right angle. So let me change views. I'll be back with you in a second. Okay, so I'm just going to try and have another go at doing this, so bear with me. So I'm just coming in for this leg of C2. There we go, a little wiggle. And that one's done. Now this is the one that's close to the cable, so I just need to be a bit careful. A little wiggle. Hopefully that's got it. We should just see. Let me just turn the board over ever so gently. Yep, that feels like that's going. Yep, there he is. So that's that one. We'll just have another go at C1 now. Here's the leg where it could fly off, we will see. Yep, you could see that the tweezers dropped there. I believe the cable is marginally moved. So look. Yeah, it's lifted up a little bit. So when we go to solder that one back down, we'll just make sure that we place that cable back down. It's not to cause any interference when it comes to reassembly. And there we go, another perfectly removed capacitor. Okay, so just for completeness, I'm just going to test these capacitors like I have with all the rest of them. And this one is supposed to be 4.7, I believe. He's coming in at 4.4. That is 4.415. That one is deemed to be in spec if it is a 10%, so that's not bad. And then we'll just check the other one just to see what that one comes out at. I've got a spreadsheet up here telling me the calculation of the tolerance, which I will share at the end. And you can check yours. That's 4.560. So that's even closer. So yeah, I think they've held up well considering their age. especially when these, I believe, are in the audio part of the path, which is why we're using the better bipolar capacitors. So, okay, I'm going to get this set up, get the board cleaned up, get those soldered in, and then we can start talking about reassembly to some degree. However, some of this is easier with this second board still disassembled, because some of the pins for the transistors are quite close to the reinforcement bars, so just bear that in mind. Okay, be back with you soon. Okay, so we're back. I've put C1 and C2 in. I'm just going to bring the microscope up here. You can see C1. I've managed to put that cable back a little bit. Ignore the dogs outside, join us. And C2 came out quite well there. You can see that's soldered in and the legs are cut. So I'm happy with that. So now it's job complete, and it will be on to the transistors, which we'll do momentarily. Okay, so the eagle-eyed amongst you would have maybe thought, well, hang on, he's done all of the capacitors, he's done the OPAMP, but he hasn't done the trim pots. And as Captain Manning would say, I'm glad you noticed that. I was just testing you. So we just need to do the trim pots now. And in order to test these, like I said earlier, it's not clear what they are. So with this multimeter, like I say, it's a cheap multimeter, but the leads are a slightly different set. They're not the original leads, they're on Amazon. I'll put a link in the description. But I like these because you can detach the actual testing prong, and you've got different attachments. You've got all sorts of different attachments. You've got sort of banana plugs, and you've got sort of battery terminal connectors. You've got spring-loaded crocodile clips. You've got all sorts of bits there. I just keep them again in an IKEA bag. But the ones we're going to use next, which we'll need a couple of times, are these little things. And they just go over the tester probe, and then they just give you a little clip on. If I can get this one to work, it seems to have fallen apart a little bit. Not sure if it's going to work. Well, there we go. You get a little, oh, you can see that, I think. A little pincer movement there, and you can just clip onto legs, which is quite handy for this next bit. So the other thing this comes with is different probe ends. You can see I've got a sharp one there on the black and a more traditional one on the red, so I just need to switch those over. So I just take the protective cap off, unscrew the probe, or the tip, whatever you want to call it. Just pop the more standard ones in. Now I can't put the covers back on, I'll put my additional pins away. But the little pincer attachments won't fit if you put the caps on. So you just get it like that, just pop it on. There you go, you can now use your multimeter like that. So this is quite handy for this next bit. And what we'll do is we'll just pop one of them on the center leg. If we can get it to sit on that outer leg, it would be helpful. There we go. And then you just need the relevant sort of size screwdriver. Just a little crosshead should do it. We'll just check that fits. Yeah, that looks to fit fine. And then on your multimeter, just change it to one of the own ranges. These are meant to be 100 and 220, I think. Let me just double check that. Yeah. So if you put this on the, for the 100, you can put it on the 200 ohm range. for the 220 you would have to go up to the next range, but you can sort of work it out. So this one I'm just going to twiddle it and see what it does. So it's going, if I go clockwise, this one's going down, 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 60 odd ohms. You just see, the lead just came off there, but I'll just see if I can just get that to sit there. Right, after some fuss I've managed to get the leads to sit on there again. Just try and hold it steady whilst I do this, perhaps. So I'm just going to rotate it, and you can see if I go anti-clockwise this time, it's going down. If I go clockwise, it's going up, it's going up, it's going up. And this one's gone past 100, so I know this isn't the 100 ohm. It's going right up, and it should go, there you go, it's gone out of range, because it's gone over 200 ohms there. So if you follow the guide, the idea is to try and keep them sat in the middle. So we will keep this, just try and sit this one down to about just over 100 perhaps. There we go, that would do for now. And I know that that's my 220 ohm trim pot. So I've got one of those, which I'm going to need. Let's have a look at the next one. And obviously there will be 2 of each in the bag. This one is currently at 57, so we'll see what this goes to. That's going down, go up. He's topping out at 104, so that's one of my 100 in. So I'll take this down to about 50 something for now. That will do. And now I've now got one of each. I can put the other 2 back in the components bag, and that's for the other amp. And that's how you tell what trim pots you have. Okay, so we're back. Now I'm going to desolder the trim pots, the original ones. We'll go for R95, which is on the edge closest to me at the moment. And it's the same principle as desoldering the capacitors. A little bit of flux. Bring the desoldering gun in and just straight over the pin, little wiggle. And if we've been successful, that should just push out. There you go, just straight out. So that's that one. Whilst I'm here, I might as well do the other one. So again, a little bit of flux. Luckily, yeah, that's pushed out. That's how you desolder the trim pots. So now we will compare the values and see what they were originally set up. Back in a minute. Okay, so we're back looking at the trim pots. This is obviously the trim pots removed from the PCB. The current one we're looking at is the 100 ohm. You can see on the screen there, hopefully you can see that, that's 34.3 ohms. It's not quite in the halfway point. And what I would suggest is when you measure these, from now on in, let's always go with the left leg of the bottom legs, because obviously if you measured it 34 ohms on this one and connected it to the right leg on the other one, you'll end up with, you know, 30, 70 or whatever the ratio will be the wrong way around. So just bear that in mind. If we have a look at the 220, and we'll just see where that one is in the grand scheme of things. So that one's coming in at 125-ish. And you can see it is wandering a little bit, and that could suggest that it was failing a little bit there. Might be a bit scratchy internally. So that's the values of our original trim pots. I will probably set it back to those values on the new ones and start from there. Or obviously feel free to start at the halfway point and adjust from there. So yeah, I'll set it to these values, get these soldered in, and be back with you in a moment. Okay, I'm back. So just a quick one, just before I do solder these trim pots in. It occurred to me to mention something. The reason you potentially replace the old ones is because they're getting a little bit scratchy. It could be that they're oxidized and that the value that you get out of it will be intermittent, might not be the same value consistently. As you can see with this new one, it's bang on stable, it's not moving at all. But we're going for the long haul here. It's going in for a long time, so you might want to just give it some additional protection. So I use deoxit failure. It just lubricates it and protects it. So just a little squirt just on the underside of it. There you go. It's more than enough. And then just use your screwdriver and just work that in. And that should mean that hopefully it will just keep it protected for as long as possible. And ensure that your amps are reliable for many years to come. So just going to do that to both of them. Set the values back to the values of the original trim pots as I've decided. And get those soldered in. So I'll be back with you in a moment. Thanks. Okay, so that's that kit complete. That's all the electrolytics replaced, that's all the trim pots replaced, and the OPAMP replaced. So yeah, if that's what you were here for, you can stop the video here, and all you need to worry about is reassembly, which will obviously be later in the video, so feel free to skip ahead to that. But I'm not going to reassemble just yet. The next job for me is worrying about these larger transistors, and that's what we're coming on to next. Okay, so we are back. We're now going to look at the transistors, and just before we jump into the desoldering and the why and the what's and the where's, I thought it was a good idea to explain what happened when I rebuilt that first Penta 1 amp. So everything you've seen so far is pretty much verbatim what I did, with the exception of I didn't take the PCB out that first time, which made it a bit fiddly, so I don't do it that way anymore. However, I reassembled all of the amp, put it all back together, put the plug in the wall, turned it on, standby, lovely, went to fire it into life, turns green, instantly turns yellow again, just as before. So I'd done all that work and it hadn't actually fixed anything. It hadn't fixed the original issue that was the reason the amp had come to me in the first place. So at that point I was a bit disheartened, and I reached out to the wider community. And a chap called Harry, who's on the Facebook pages for the B&O equipment and what have you, great guy. He's been very helpful to me on many projects. And he actually said, well, have you tested the main transistors? I said, well, I've got to be honest, I don't know how to even do that. And he said, well, simplistically, start probing about with the multimeter and see if there's any shorts. So I'm going to show you that now. Obviously these aren't in circuit anymore, but these are actually the components on that original Penta 1. I kept them because I always imagined that one day I would show this, so I'll show you this to you now. So simplistically, the multimeter is yet again on continuity. Got continuity there. So I just started probing about, and I started on this side, and there's nothing on the pins here, like that. And then I went, you know, pin to pin, maybe 1 to 1, 2 to 2, what have you. And I checked to see if there was any shorts across them. And for the most part, there wasn't. It just seemed to be fine. Then I went over to the other side, which is where the green components sit. And again, I did this, and almost instantaneously, suddenly there was a short. I'm not sure if it was pin to pin or what have you, but there was a short. and it was across all of them. So my immediate thought was that maybe all three of them had failed, but actually what had happened is when I get to this third one here, I believe, yeah, so there's a direct short across all of the pins. Internally it's just quite literally failed, and that was actually triggering and shorting all of the other ones. So it looked like there was a bigger fault than there actually was. So theoretically I could have got away with replacing this single transistor. Off the top of my head now, I don't know what it was. Just for reference, all of them sit in between TR25, 26, 27, 30, 31, 32. And I don't know which one this would have been now, but my gut would be as it would have been the first one in the circuit, and potentially, you know, there was a lightning strike or something, or a power surge, and it just knocked that one out, and that's what triggered the reason for the amplifier not working. So that's simplistically how you can check them, but there is a better way of doing that, and for that I'm going to have to fire up a bit of MS Paint and draw some pretty drawings, and I'll be back with you. Well, in fact, I'm going to pass over to myself on the computer in the studio, so to speak, and be back with you in a moment.
Right, okay, we're back. I've spent a lot longer than I wanted to spend on this section, but it was important to get the information right. So I just want to give a shout out to Gadget Reboot. This video that I've got on screen now has been instrumental in my understanding of how to test transistors. I've simplified the information for this video, but I would suggest you go and have a look at the original video and give him a subscribe. The parts in question are both NPN and PNP, and if you have a look at the part on Mauser or DigiKey or whatever you want to do, you'll find the data sheet. And if you have a little look at the data sheet, it shows you the arrangement of the pins and what they do. That information I have simplified into this page, and this page would be in the source information pack, but obviously feel free to pause the video and have a read. But simplistically, I've put up the chart here of the transistors, what their original parts were, what I was hoping to use and what I am using, and then looking at Mauser, what they are. So you can see that the first three here are NPN and the last three are PNP. So I've taken the pictures from the data sheets and reworded them to be a visual representation of the original parts. And I've listed below the tests that you will need to do for both respective parts. As far as I understand it, this is the best way to prove that they are indeed not faulty. So what we'll do is we'll switch back to the camera, I'll do these tests and we'll see what results we get.
Okay, so we're back at the bench, and I'm just going to run through that previous slide that we just saw there and run through the tests. So in order to do these tests, you need the multimeter, and we need to set it to the diode setting. So that's that one there. Hopefully you can see that. And we're going to run through that list of tests now. So it says for the part 2SA1302, which is the green ones, put the positive lead on pin 1 and put the negative lead on pin 2. So I'm just going to do that now. And we can see nothing is coming up on the meter there. And it says that should show no reading, which is correct. That's what we've got. So test 2, put the negative lead on pin 1 and put the positive lead on pin 2. And it says that should show a positive voltage reading, something like 0.534. And what have we got? We've got 0.525. So that sounds about right to me. Test 3 says positive lead on pin 1 again, and negative lead on pin 3. And again, we've got nothing on the meter, which is good. And then finally, test 4 is negative lead on pin 1, positive lead on pin 3, And that should show a positive voltage, which it is. It's showing 532.532 there. And if you've done it correctly, test 4 should be higher than test 2. So if we just go back to the middle pin there, that's 525, and the third pin is 532, so it is a higher voltage. So that says to me that that part is actually good. And had I not have replaced that part, that would have continued to work fine. Let me just skip, let me just see here. Yeah, so the faulty one is this one here. So let's try and do those tests again. And it will be interesting to see what we get. So if we put positive lead on pin 1, negative on pin 2, oh look, we've got a voltage there. It's going to be 0.012, so it's small, but that's incorrect. That's showing a reading, so it's failed that test. And obviously it failed the continuity test. And I would assume if we do the same, yeah, we've got a reading on pin 3 there as well. So you can definitely tell that this part has been faulty. And that is how you test PNP transistors. Okay, so we'll now move on to doing the second set of tests, which is on the NPN. So this is going to be the black part, and this is part 2SC32H1. And we will go through those tests now. So it says positive lead on pin 1, and it says negative lead on pin 2. And this should show a voltage, something like 0.561. What have we got? We've got 0.565. Switch the leads around, negative on pin 1, positive on pin 2, and we've got no reading, which is correct. That's what we want to get. And then test 3 is positive lead on pin 1 again, negative lead on pin 3. And again, we've got a reading there of 0.566. We'll just check that there is no reading when it's in reverse. There is no reading. So as far as I'm concerned, that part is good. And we've got 563 there. We've got 565 there. So that looks to have passed all of the tests. So I would say that was a good part. And I think realistically with that Penta 1 amp, it was only that one part that had failed and it was triggering a bigger issue. And I could have potentially left them. But speaking with other people, it sounds like if you're going to replace one, you're better off replacing all of them and making sure that they're matched components so that you get no issues. And that's what I did. I'm pleased to say that the fix for the Penta 1 was successful and that those amplifiers actually came back to life. I'm doing this on mine as a preventative issue because I don't think these parts are at fault. But let's jump into testing those now and see what we find out. Okay, so we're now going to attempt to test these in circuit like I did on the previous amplifiers. And we've changed the multimeter over to just continuity mode now. So we should get continuity on the pins. And if we just go through them, I've noticed these have got quite a lot of sort of flux residue from factory. So you just want to scrape away at them a little bit just to see if you can get some sort of direct short, which we're not getting. That looks fine. And we don't appear to be getting any sort of direct short there, which is good. Now if we look, it actually denotes on the PCB what is the emitter, collector and base. And if you actually go from emitter to emitter, you will get continuity because obviously they're connected. So that looks fine. So I wouldn't suggest that there's a fault potentially there with a broken trace because they're connecting. So I'm happy to say that those three devices at the moment appear fine in circuit. We'll just try the other side of the board with the black components. And there appears to be no short there or there. Or there. And similarly, the emitters are connected, so we can see there's no fault with a broken trace there. So I'm sure if I did put this back in the casing, it would be fine. But like I say, I'm here, I've got the parts, so I want to continue to replace them. So bear with me, I will get those out of the box, or get the box, sorry, and be back shortly. Okay, so here we are then. We've got the box of components that have come from Mauser. I opened the box just to check what it was, but it was indeed what I needed. In the box, you've just got your packing slip at the back, which will have my address and what have you on. And then you've got the components themselves. I haven't opened this at all, so this is just as it comes from Mauser. And in here we've got 2 anti-static bags. And we've got the 96G and hopefully the 95G, and we should have 6 of each. Yep, so that's enough to do both amplifiers. So what we'll do, let's just get one of these out of the bag. Just have a little look. Just compare this to the original parts. So this is a 96G, you can see you might be able to see the part there. And the 96 is to replace the 3281, 3281 being the original black component. So that, if we were to do the tests on that quickly, that would, let's have a look here. That would be, just make sure you can see the screen. That would be a positive lead on the pin 1 and a negative lead on pin 2. And that gives us 0.519, and then same here, 0.535, which is higher, so that's correct. And if I reverse the leads, nothing. So that's obviously a good part. And you can see it's the exact same form factor. It's just a newer revision of it. The heatsink backing plate is the same. The only difference, of course, is that if I bring in one of the green components, you can see the new parts are shipped flat. The pins are not bent in any way. And if you look at the older part, the pins are bent. Don't know if I'll be able to. Hopefully you can see that. And the reason for that is that the part steps out from the PCB to be flush with the heatsink. So when we fit these, we're going to have to bend these pins back. So it's a pretty simple affair. Just get yourself a set of pliers and just try and mimic that bend. So what I found is, I believe, is if you do the middle one first, because that's the more awkward one. So we want to grab it up to just the end of the leg, bend that up towards you, and you just want to try and get that bend to be the same as the original. That looks to be almost correct. I think you could do with a little bit more bend. Obviously be gentle, you don't want to snap it. And then you want to allow for a step and then straighten it out. So once you've done it once, you can pretty much get it repeatable pretty easily. So I'll just come down a little bit and just try and get that step in. And that is how you make the pins on the new ones match the pins on the originals. And just take a moment to do that to all of them, so get them ready, and then they'll be ready for soldering. Okay, so we're now ready to prepare to desolder the original components. And as you can see, there is quite a lot of solder and the traces are quite thick, so you're going to need a lot of heat to get these out. And also just remember, obviously if you look at the brand new ones that we looked at a moment ago, the legs are quite thick. So if you use the same pitch desoldering end, you'll find it won't actually fit over that pin. So when you do buy the drawer tool desoldering station, it actually comes with this little bag here. And in this little bag, you've got a couple of extra filters, and you've also got a couple of extra ends. Now, as you can see, this one is actually brand new. I've never used that. That's the middle pitch. So we've got the finest pitch, which is in my gun at the moment from earlier, middle pitch, and then the thickest, widest pitch. If we just look at that, you'll see that actually goes over the pin quite nicely. So when it comes to desoldering, we should be able to get on there and get that solder out. So obviously let the gun cool. I haven't used mine for a little while because I've been doing all of that documentation. So you just undo the collar, lift the collar, the end will fall out, and then I will just take an opportunity to just use the declogging piece. It comes with 3 of these depending on the size you're using. I can't offhand find the other 2, so I just have to use this one for now, but that seems fine to me, so I'm happy with that. Because what you have to be careful of is that you don't clog back here, because it takes forever to clean. So I'm just going to put that bigger end on, put the collar back on, just finger tight, and that's it done. And just so I don't lose those, I'll pop those 2 back in the bag. And that's just ready to go. So we will bring the desoldering station up to temperature, wait for that, and then I'll be back, we'll flux it, and we'll try and remove these components. Okay, so the soldering station's up to temperature now. I've just knocked that up a touch. I've taken it up to 320 degrees centigrade on that one. So I've just had a quick test, and yes, that did melt that fine. So let's just have a go at that now. So I'm just going to put that down over that pin. You see it's melted, a little wiggle. And I'll just clean the end. And the gun is nice and unclogged. If you hear that noise change, it means your gun is clogging, so stop before it gets completely clogged. Let's move on to the next pin. Little wiggle. And the final pin. So I'm just going to have a look here and just see realistically if these pins have desoldered themselves. Let's see if I've got the flat blade there. So what you've got to be careful of is you don't want them to still be stuck in any way. And I think perhaps they are. Okay, yeah, that's fine. You just do not want to rip that pad off the board, because otherwise it's going to be annoying. But as you can see, that one actually came out perfectly fine, and we'll continue and do the next 2 before we look at them. And we'll just see if this part is going to come loose. Yep, it's come loose as well. And I'll just take the opportunity to just quickly try and clean these pads up, get new cotton buds. Just dip that in some alcohol. And just clean those up a little bit, just to show you that no damage has happened, and they're going to be completely serviceable for the new parts. Just got all that flux residue off. And hopefully you can see that they've actually survived really well. Those pads look like brand new, and as long as you're careful, you'll be able to replace those components and have no issues. So I'm just going to go ahead and remove the rest of these. It's the same process all the way around, and I'll be back with you in a moment. Okay, so those have all been desoldered now, and as you can see there was quite a lot of flux residue left over from factory, it seems now, and it was the same on the other Pentas that I did, but you can see now that's all been cleaned up, and as far as I'm concerned those are literally like brand new. I don't see any issue with that, so I'm happy with that. What we will need to do now is just clean this side of the board. Just a little bit of thermal compound there that's just on the board that shouldn't be, so I'll just clean that up a little bit and we'll be ready for the next stage. Okay, so the board is cleaned up now, and I'm happy that there's not really anything further to do on it. The only exception being that the two transistors that we're not replacing on the top have still got thermal compound on it, and that needs to be cleaned off, ready for renewal. So you could try and clean this off with alcohol and what have you, but it's not the greatest solution. So the best thing to do is actually just use proper computer thermal compound cleaner. This is a tin cleaner. It's just a sort of lemony smelling substance, and you just put a little bit on. I just put a little bit in a cap actually. Just put a little bit in the cap, just a couple of drops. And just get your cotton bud, soak that up. And if you just, let me see if I can get the right angle. If you just start just rubbing on that, you'll see that it instantly just starts coming off. And it's really designed for this, and it's just good at getting the bulk of that off. And just use a dry cotton bud or a piece of tissue just to mop that up. It's just a little bit on the edge that I want to get rid of. And you can see that that heatsink is nice and shiny now. That's nice and clean. Or that thermal spreader. So yeah, that's ready to now be reassembled. So I will just do the same with the other one, which is slightly worse. But that's done. So the next stage now is actually not to solder on the new transistors. The next stage is now to prepare the heatsink for them. So we'll switch to that next. Actually, just before we move on, I just thought it would be interesting to note the differences between the Penta 1 and the Penta 2 components. It looks like Toshiba went through a logo change at this point for some strange reason, and you can see that on the left are the original Penta 1s, and on the right are the components that come off of my Penta 2s. So it's just an interesting change. Okay, so now we need to move on to trying to remove all the thermal compound on the heatsink. And again, the best way to do this is with a little bit of the tin cleaner, and just start rubbing it, and you'll see that it starts to loosen up quite easily. You're going to get through a lot of cleaner here, and probably a lot of Q-tips, I suspect. But it's important to get it all off, get it nice and clean, and you know that when it comes to fitting the new compound, it's going to be good for hopefully another 20 years or so. Hopefully it's somebody else's problem by that point, but let's make it nice and clean, nice and reliable, and I'll come back to you soon. Okay, so I just spent a few moments just trying to loosen up some of that thermal compound there, and I've just rubbed a nice helping of cleaner over that. And we're just going to see if we can get this piece of glass to lift, this piece of plastic here. So I'm just going to use a blade, just try get the edge to start. Just trying to see if we can get it to lift in one piece, and I'm not sure if that has. Just going to try with the other end of the blade there. What we don't want, which we don't really want it to delaminate from itself. Also, sometimes you can use some tweezers. I'm hoping that's in one piece. It's a bit too early to tell, but it looks... Yeah, it feels thick, so that feels like that is in one piece. I'm just going to lift that away now. I'll just pop that just to one side for a second. And we'll just try and just clean away some of that compound. And yet that confirms it. That did come away in one piece. So that's brilliant. That's exactly what we need. So what we need to do now is we just need to clean this piece, clean both sides, try and get it back to as clear as possible, and then that will be ready to go back on. You'll notice this piece doesn't have any holes in it. This piece is just for one of the smaller transistors, so you need to make sure you remember what order they go in. And I don't know if you can see it, but some of the bigger ones, it's got a hole in it to represent where the hole is on those bigger transistors. So I'm going to go ahead and I'm going to try and just lift a few of these. Let's just try this next one, just to see if I can maybe get that one to lift. Yep, that one looks to be lifting. Yeah, and you can see that one, you can see the hole there. So that's the difference of the designs. So I'm going to go ahead and remove all of these, clean up the heatsink, and then bring it back to the bench when it's done. Okay, so we're on day 3 of recording now. I had no idea how long this would take to record and get all the shots lined up and stuff, so please be kind in the comments. I've started editing the video. I know it's extremely boring to watch, so apologies about that. So I've cleaned up the amplifier heatsink and we'll look at that momentarily, but I just wanted to quickly look at the pieces of glass or the plastic isolators. So I think from left to right, these can obviously come off the best, and then there was degrees of failure, shall we say. This one, if you're wondering how I ended up with a crease, that was my mistake when cleaning. Be very careful to not catch yourself on it, because I caught my finger on the edge and buckled it, hence the crease there, which is not ideal. And you can see that the blade damaged the bottom of these two here trying to remove them. So just be very, very careful when removing these isolators. Presumably you could cut some new ones out of some thin plastic sheets, but what I don't know is the safety aspect. I don't know if they would be geared up for the temperature you're going to put it through. Would they melt? Would they potentially be a fire hazard? So you really need to try and keep the originals, because obviously they were geared up for the job. So just thought I'd show you that. Okay, so this is the heatsink cleaned up. As you can see, I've managed to remove all of the heat thermal paste from the sides of the amplifier. And this proves that you can actually do this job without removing the side panels if you wish. Like I say, my preference would always be to remove them, because I like to wash the heatsink and fully clean it. But mine wasn't actually any that dusty, so it wasn't absolutely necessary, just would have been a nice thing to do. So now the heatsink is fully clean, we can start to think about refitting the transistors. And how I like to do this is I like to fit the transistors to the heatsink, thermal paste them, clip them in, and then lower the PCB down over the top of it. This is very tedious, but I prefer to do it this way because I don't want to have stress on the pins when it's in production. By doing it this way, you know that the pin's already lined up with the PCB holes, and you know that there's not any unwanted or unnecessary stress on them. Whereas had you have done it before, you may be bending them to where they need to be clipped, and you could cause stress on the board. Okay, so now we're at the point where we need to actually reassemble the bracketry system for this, the speaker connections. So what we'll do is I'm just going to carefully take off the pieces of tape which I put on earlier just to secure it. And then we just need to reassemble this assembly. So easy enough, we can pop the piece of isolation card in. Note where the hole is, that's for your trim pot to allow the screwdriver to go through. So it just needs to be in this orientation. And we'll just shimmy the board over a little bit. And these parts are actually identical. And what you need to make sure is just make sure that they're in this orientation and that you actually have the lip on the outside. So I'll just pop this one on this side. I'll just ease it into position. And you can see the kind of angle at which this will all sit again. Same principle with this side. And what I think I'll do is I'll just click these into position on one side first. Now, what you might find is because of the way it's spring loaded, you'll notice I can't push down on that. So we need to actually try and squeeze and manipulate them back into position. Whether I'll be able to do that with a flat head, I don't know. We will see. Because what you don't want is you don't want to damage the board, and obviously you don't want to snap the clips. So bear with me, I'll be back in a moment. Okay, so what I've just done is I've just used a little bit of this silicone grease as a sort of assembly grease. And again, this was an Amazon purchase. But I've just put a little dab onto a cotton bud. I've just put a little bit on top of the prongs and a little bit on the underside of the metal band, and that's just to try and ease and convince it to reassemble. So I'll just pop that back where it needs to be. Just get it under that board there, just move that cable out of the way. And you want to try and keep it as square as possible. Again, hold and support the board, don't let it bow at all. You can see, there we go. I'll just do the back one. Just rock it, and you can see it's just starting to squeeze in. There we go. And we'll do the other side. So just lift the board, pop that one back to where it needs to be. Go for this front one first. There we go. Go for the back one. There we go. So now it's just a matter of lining the board back up with its prongs that it sits on. So you can see there's just two little metal divots that should sit in. There it is. Makes it sit nice and square. And then it's just a case of putting the screws back in, which is the the smaller black ones at the front. Don't do them all the way up until they're all in. Small black one on the side without that sort of grounding cable. And then we just have the little grounding cable just to bring round. And that one will need to go on there. And I'll just reposition the camera to show you that. Okay, so I've just taken that front screw back out there just to loosen up this side of the board. And the cable, I just checked the video footage from earlier. The cable actually needs to just come up actually between the boards, and you can just obviously manipulate that up in like I have there. And then the serrated washer goes on first. Then the bolt goes through the cable, through the washer. Which I'm just a bit fiddly to do this with the camera in the way. There we go. You can see it should look something like that. I'll just put the black screw back into place. And now they're all in, I'm happy to just do these up finger tight for now, because it may not quite line up with the heatsink holes. So there's no point doing them up fully tight just yet. Okay, and there we go. So that's now the board reassembled. Okay, so now the board is reassembled, we'll just make sure that it still fits down in the body. So what you do is just lift it up, let the cable drape down in the centre. You want the front end to go in first because these pins have to just clear in to where they belong. And then just lower the board down in, and you can see that fits perfectly fine. So what we're going to try and do is attach these transistors back to the heatsink where they need to be. And then we'll just keep tweaking the clamps and adjusting them until the legs line up perfectly and the board just drops over the top. Okay, so just before we get started, I just want to just explain the thermal compound. This is the type that you might be most familiar with, especially if you do computer repairs. This particular one is a Cooler Master thermal compound, and you notice it has a sort of grey colour to it. You may be able to just see some of it on the end there, and that's because usually they call this like an Arctic silver or a silver impregnated thermal compound, and that's because it has a better heat transfer. So in computer terms, this one is the better one to go for. Cheap computers you may find just have a sort of silicon based thermal compound, but good computers will always have the silver type. Now the concern is because there's silver in it, is it electrically conductive? And it seems that some people suggest it is. And what we've got to be very careful about here is if you have your isolator and you have your transistor with your metal backplate, and you have that like that. Now hopefully if you get it perfect and you have just enough thermal paste that it's not oozing out the sides, it won't touch the heatsink. But if you used the silver based compound and it did leak out past, it could potentially create a join between the spreader and the heatsink, and if the paint is scratched you could potentially have a short. So it's not something that you want to risk, especially if, for example, it came down and touched the pins, you could have a direct short quite easily between the pins and the heatsink, which is not something we want. So I don't want to risk using silver-based thermal compound, so I will actually use the original white style compound that came in the amplifier from factory. And again, this was a Amazon purchase, and it was probably completely full when I started, and I've used this to do 2 Penta 1 amps, and obviously now I'm going to use it to do this 1 Penta 2 amp. May not be quite enough for the second amp, but I can always buy more. Okay, so I'm just going to make a start on applying the thermal paste. There's lots of different ways in which to do this, so this is just the way I've done it. It may not be the way you want to do it, but feel free to do this the way that you want to do it. So I'm just going to start to slowly squeeze out some of the thermal paste, and I'm just going to move it around and just make sure that there's a little bit of paste all over this back plane. A little bit of thickness to it. And then we're just going to lay the isolator on top of that. You can just see that now. I'm just going to try and line the central hole up as best as I can. It doesn't have to be perfect because it's not used. You can just see, there we go. That looks like there's a good covering of paste within that. So I'm just going to do the same thing again, just now on this side of it. I feel relatively confident that that will be more than enough paste for this job. So now we can attempt to put that back into the amplifier. Okay, so I'm now going to try and put this back into the amplifier. Just going to wipe the heatsink there and make sure that you've got a clamp ready to go on. And what you want to try and do is don't click in both sides, just click in one side and try and get it to hold under its own weight, so you've got a little bit of adjustability when it comes to the full reassembly. So I'm just going to take my part and I'm just going to try and put it where I think it should go. So I think that's about where it should go. Now normally I would do this flat so that it's got gravity on my side. And I'll just bring the camera down for this. Okay, I'm just going to bring the clamp in. Just going to sit it down one side and then just try and bring it across. There we go. So that's now holding it loosely. And I would suggest about there is probably right. So I'm just going to click down one side. I'll do the inner side. There we go. You can see that's holding that relatively tightly, but not so tightly as if you can't move it. Okay, and what we're going to do is we're going to bring the board back in. I'm just going to try and feed that cable back through. And again, we need to feed it in at the front. And then bring the board back, and what we're trying to do is get these pins to line up. And actually, there we go, I've managed to achieve that. So I'll move the camera. And there you go, you can see the board is happily sitting on those pins. And there's not any huge amount of resistance. I think the board will push back and sit fine. May just push. There we go, just push it back in a little bit just for a bit more clearance. And now I've got my gauge and I need to know to put all the other ones at that sort of depth and work my way around. So I'm going to start to do that, and I'll be back with you in a moment. Okay, so just a quick update. As you can see, I've managed to get the first 2 transistors back in, and you can see what I've actually done is just line them up as best as I can. I've pushed the clips home, and there's still a little bit of play in them, which is brilliant, and that's allowed me to just get that lined up so that that board will just sit over those perfectly. As you go around, it gets more and more awkward and takes longer, but if I hit a problem, I'll stop and show you how I remedy that. Okay, so I've just managed to get the first 3 in, and actually they went in really well. The third one was ever so slightly off, and all I did was just lift the board and then just rotate it ever so slightly, look straight down on it, and just keep checking until the pins align, and it will lift on and off. You see that? Just a little bit of fiddling and it will go straight back on. Okay, now the problem comes when you do the 3 on the other side, and I'll be tackling those next, and hopefully, well, hopefully not, but I might have more to show you. Okay, yeah, so this is where it starts to get tricky now. So I've got the first 3 in on that side, and I've managed to get the 4th one in there, but we're now on transistor number 5, and it's not quite lining up, and no matter what I'm doing on the wiggling, it's not quite right. Now if I come in overhead, which is, I may have to reposition the camera in a moment, but I can see that the pins are ever so slightly a little bit to the right and possibly a little bit too far in. So I need to just straighten that up and potentially bend those pins out a little bit. I'll just reposition the camera to the front so you can maybe see that. So hopefully you can see that the pins are a little bit off there in terms of alignment, and then I'll now try and get above and see if I can show the fact that I can see the pins when I move them. Okay, so I've just repositioned the camera again. I'm just going to show you that the pins are too far in, but if I push on it slightly, see how it appears under the hole? And they're all the same. That one's, yeah, he's just out of view, you can just see him. So what I'm going to do is I'm just going to take the board off. I'm just going to just push them out ever so slightly. I'm just going to try and refit the board again. And there we go. That's worked perfect. You can see that there's going to be no strain on that at all. They will solder in and be lovely. So 1 more to go. Okay, so I don't think I could ask for a much better outcome there. I can't quite believe it, but it went in first try. I managed to get the board to just go straight down first try. When I did the last pair of amplifiers, it actually took me almost an hour to get the last of these pins to line up, but for whatever reason this time it's gone perfectly fine. So you can see that the board will just rock on all of those pins nicely. There's no strain, no stress, so I'm confident that when it comes to soldering that in, that they'll last a long time and be quite happy. So I'm just going to gently pull the board back out, and the last thing we have to do is actually prepare for the thermal sensor and the 2 smaller transistors on the back there. So what I'm going to do is I'm just going to move the camera and do that now. Okay, so what we need to do now is just get the isolators ready to go in. So we'll just use a little bit more thermal paste. What I'll do is I'll just hold it steady. I just want to get, just try to focus there. I just want to get a very thin layer of grease all over there. And then we just need to lay that one in. Just try and pick that one up. We'll just lay that one roughly where it needs to be. just until you see a nice consistent layer of grease underneath it. And we'll just do the other one in the same way. Okay, so I'm happy with that. So what we'll do now is we'll lay the board back into the housing and I'll show you what to do next. Okay, so I've laid the board back in the housing now and I'm happy that that's, you know, seated quite nicely now. So what I'm going to do is I'm just going to screw the board back down to the heatsink so that I know that it's all the way down. And just make sure that you don't cross thread the screws or anything untoward like that. Of course, because the camera's in the way, I can't quite see what I'm doing here. Okay, so as you can see here, these back brackets aren't quite lining up right. And as I said, I was expecting this. So I'm just going to loosen off these screws now, both sides. Just make sure that they're loosened off at the front. And you should be able to just adjust these now. And just pull them to where they need to be. So I can see that one. Just needs to be pushed over slightly. There you go. And you can see if it's there, that should fit fine. Okay, so that is the balance now fixed and the board is now rigid in the case, so we can now turn that over. And what we should notice is that those small transistors at the back are not touching those isolators yet. So what we need to do now is just put some thermal compound in between them and then bracket them down. Now you could try with the nozzle, but that is a little bit big perhaps. So maybe if you've got a smaller syringe, or perhaps if you could put some thermal paste on the end of a cotton bud or something like that, or a skewer, and try that way. But I'm just going to try putting it in with this for now on one of these. So I'm just going to try the green one first. It may not be the neatest in the world, but I'm hoping it will do the job. Yeah, that looks like that's going to work fine. So I'll just get my clamp down bracket and just ease it over. There you go, you can see I've clipped one side in there, the other side, and then a little push. And that looks fine. You can see that's pushing down nice and tightly because I can't even move the plastic isolator. So that looks good to me. So we'll just try the same trick with this other one here. So I'm just gonna just try and get my nozzle behind it. It's a bit more tricky as this one is a little bit closer, so I might just bend that one out ever so slightly. I'll just put a pea-sized amount of thermal compound behind there. We'll just press it down in. That looks fine. And again, I'll come in with my clamp. This is a little bit tricky to try and do so the camera can see. I'm just going to use the flathead just to ease it over the other side. There we go. And I'll just click that in now. And that is all of the transistors fixed back to the heatsink. Okay, so the last job we need to do in here really is just put a little bit of thermal paste behind that sensor at the front. So I'm just going to squeeze a little bit just down the front of it, if I can get the right angle. And that should squeeze down the front of it, but I will just spread it out a little bit. Just add a little bit more. And that should allow it to do its job when it comes to reassembly. Just something quickly to note, you may remember way back at the start of the video, I was looking at the speaker cable for a denotation on it. Hopefully you can see this. There is actually some writing on that speaker cable. I don't know if you can make that out, sort of orange text. It's going down one side of it. Now, if we actually unravel this a little bit here, you can see that the cable that I put the black marking on, it's actually the cable with the writing on. So if you didn't know which way round your cables were, that should be the negative. And if you want further proof of that, if I hold a pin to that cable that has that black mark on it, and I just ground myself to the chassis, we get continuity. Whereas if I do it to the other one, we don't. So that's how you know which way round to connect your speaker cable. Okay, so once you're confident that you're happy with how the transistors are sitting and the board is screwed in nice and square, you can now proceed to soldering in the transistors again. So what we will do, we'll just use the 6040 leaded solder. We use the flux pen and we use the soldering iron. We'll start off at maybe 250 on the temperature and we'll see how we go, because if you remember we needed 300 plus to desolder them, so we'll see how we go with this. Okay, so I'm just going to try and go for this pin here, just trying to add a little bit of flux around it. I've already tinned my iron, got my solder at the ready, and we'll just have a go and see how we get on with soldering this. Seem to have some moronic children screaming in the background. Okay, so I'm just going to try and clean that up with some alcohol and just see how that looks. Okay, so hopefully you can see that that has soldered. It doesn't look bad, but I'm not too sure if it's gone all the way around. It's hard to tell. So I might just try and get the microscope on that quickly just to double check that. Okay, so perhaps I'm just being overcautious. It looked like it wasn't a complete solder joint all the way around, but looking at that, that looks fine to me. So I will continue to do the rest of them and come back to you shortly. Okay, so I'm just going to move on to the next pin. I'll see how I get on soldering this. It may be that it's easier to cut the first pin off to get some additional clearance, but we'll just see how we get on with this. You can see that looks like a good joint. I need to reflux the last pin. You can see these are quite large pads and pins, so they will take a lot of solder to get them to flow right. That looks good. So I'll just come in with a little bit of alcohol. Just to clean around those pins. I'll just brush that off as well. And that's how you resolder the transistors in. So you just need to cut the legs off. Don't cut them too close to the solder, there's no need. It's probably going to be hot. Okay, and there we go. That's the first one done. So I will continue around and show you the results. Okay, we're back. And as you can see, I've finished soldering the transistors. So I've done 1, 2, 3, 4, 5, 6. And I've also cut off the legs. So I'm just going to bring that in under the microscope now, just so you can see that a little bit close up. And we can see this is transistor 26. And I'm quite happy with that. It's not quite as fully covered as before because you can see the little notch in the original pads, but I'm still happy that the solder is covering the whole of the pad and it looks healthy. So I'll just move on to the next one. So this is 25. You can see similarly, I'm happy with that. That looks fine to me. And then we've got what's that one? 27. And again, there's a little bit of pad showing on the middle pin, but I don't think there's anything to particularly worry about. If we come over to the other side, TR32 there, a little bit of flux residue, but you can see the pins look well adhered to the board. We've got TR30 there. And finally, TR31. That was a little bit fluxy, but other than that, I'm happy with the soldering. So I'll just try and hold this up to the camera a little bit as well, just so you can perhaps see it as you would see it with your sort of naked eye. And I think that looks fine. I don't think it looks any different to any of the factory soldering, so I'm quite happy with that. So moment of truth, I guess, is I just need to check to make sure there's no shorts across any of the pins. So just go through all of them. Just make sure there's no direct shorts. So there appears to be no shorts, and we should be able to go emitter to emitter, I believe. Yeah, that sounds fine. Yeah, so it looks like they are connected perfectly fine, and now we can move on to continuing to reassemble the amp. Okay, so just before reassembling, I just wanted to take an opportunity just to show the board inserted back into the housing. And as you can see, compared to the initial footage when the board was being removed, it's a lot cleaner, it's dust free, and all the capacitors have been replaced. Okay, so at this point, if you weren't replacing the capacitors in the lower transformer assembly, you could actually reassemble the amplifier now, feed the leads back through, solder them in, and move on to calibrating the trim pots, which we will do later in this video, but not yet. So like I say, if you're not doing this, you can skip this section, but I am, so let's proceed. Okay, so we're now going to look at this particular kit, the CK082. It doesn't actually come with any instructions in the bag, it's just for humongous capacitors. Let's get one out and have a little look, see what the dealio is here. And yeah, they are pretty damn big. So what we will do is, actually they're supposed to replace these capacitors here. I'm looking at this and I'm thinking this is smaller, which is kind of interesting. So it will be interesting to see how they fit. Okay, so I've just double checked, and yes, these are indeed direct replacements for the capacitors in question. In fact, they're heralded as an upgrade. The tabs, you can see, are going to be pretty much identical. The only difference is they won't fit in the entire body, so perhaps there may need to be a spacer at that end. We'll see what they fit like when we get there. So for now, we need to remove this casing, and in order to do that, you need to first remove the screws for the secondary smaller transformer. So there's a screw on the back here. And there is a screw hidden just underneath this tape in the middle. And I'm not going to take that tape off simply because it's holding all the cables and it doesn't need to come off, you just need to remove that screw. Okay, so once that's removed, you can just lift this up and just pull it to the side ever so slightly. Then on this housing, there's a clip at the back. And this one is just to sort of squeeze and that pops out like that. Just click it back so you can see the difference. Yep. And then on the front, it's basically the same but inverted. And you just do that to release that. Now I assume at this point you can just wiggle this and this will come out. There we go. And you can see how the screw goes down through that piece of casing. So now we see the capacitors in all their glory. And you can see these are row capacitors, and they are 10,000 microfarad, and they're 80 volts. Now, before you start playing too much with these, Yeah, they are loose. They could still hold charge. My amplifier has been unplugged since November, so they're unlikely to still hold voltage, but we will just double check. I'm not sure what voltage they would hold normally, but I'm going to put the meter onto the 20 volt range. I'm just going to touch each terminal. You can see I'm just getting a reading there of 0.03, and we'll just try that with the capacitors in there, and that's getting 0.02 on the meter there. Just see that. So they're not holding a lot of volts, so I'm happy that this is relatively safe to work on. So by the looks of it, we can just lift up these capacitors and then look at removing them. Now I would like to try and save this foam if I can, but it's usually very brittle, so we may not be able to. Let's see. Okay, sometimes these can literally turn to dust, so I feel quite lucky that that hasn't happened to this. Actually looks like the glue is maintained itself quite well over the years. So that's it, I've just removed that from the first one, and you can see that capacitor will quite literally just lift out. So now we need to look at desoldering. As you can probably see, the wires, there's a pair of wires to each terminal, and they will go through and seemingly wrap over. So we will have to attempt to remove those in one piece, which I think I'll use the soldering iron to start this. So let me bring that up to temperature and I'll come back to you. Okay, so the iron's up to, temperature is up to 250 odd degrees. Not sure if that's going to be enough because this is quite a hefty tab. I'm just adding a bit of flux there, and we'll see how this goes. Again, it might be wise to actually change iron tips for this, but we'll see how this goes. So you can see the flux is actually bubbling, but the solder isn't really melting. So I think I'm going to need a little bit more temperature for this. And I'll bring the camera down closer so you can see. Okay, so I brought the iron up to 290. And we'll just see if that manages to make it melt at all. Doesn't seem to be melting at all. Just bring in a little bit of solder just to add to it, just to see if that helps to get it started. So you can see I was able to actually pierce through the tab there, so the solder is starting to melt up. There we go, you can see the wires are loosening up now. So just see if I can force bend that wire out a little bit. See if I can do the same with the other wire. That is very hot. Okay, so you can see on this occasion, I don't think this is going to work. It's starting to melt the sheathing of the wire where it's just getting far too hot. There's just too much metal solder to really get this out effectively. So what I'm going to have to do is have to cut it out, unfortunately, but I think there should be enough wire to get this nice on the new capacitors. So I'm just going to cut right at the base of the tab. Just cut that off, and we'll tidy up those cables later. And I will see if I can do the same with the other side. There we go. And yeah, it would be interesting to know if this capacitor can still hold that much capacitance. Don't know if I've got a meter that will go that high, but it would be interesting to know. Okay, so I was just trying to replace these capacitors, and it just dawned on me that I wasn't actually sure of the orientation for the new capacitor. So I've just referred to the service manual, and it appears that this one is 6C1 and this one looks to be 6C2. And the reason I say that is this power connector is actually called P5, and you have pin 1, 2 is missing, 3 and 4. So if we look at the connector, we can see pin 2 is missing there, so that would mean that 1 is white, 3 is blue and 4 is orange. And if we look at the service manual, which I'll put this up on the screen now, it seems to suggest that pin 3 goes to the negative side of 6C1. So if we look at pin 3, that's blue, so that means that this must be the negative side, which, looking at these capacitors, you can see that there's sort of a cross on that terminal, which would suggest possibly positive. So that seems to make sense, because the blue did go to this side and then the orange goes to this side. And it suggests that pin 4 actually goes to the positive side of C1. So that would tend to suggest that that's positive, that's negative. And I'm assuming when it comes to these new capacitors that this line denotes negative, because there's nothing else to suggest otherwise. So here's hoping that's correct, and we'll proceed. Okay, so based on the findings in that previous video, or section of the video, I'm going to cut this one out now. I've labelled the capacitors just so that if I do get the opportunity to test these, it'll be interesting to see what they're at. This one is quite tight. The top cables are white and they should snip, and you should be able to pull them in ever so slightly, and that should be fine. But the bottom cable is very tight, so it's going to be hard to show how to cut that. But essentially the bottom cable is a blue and a black. You should be able to see in there the blue, possibly the black, possibly. But the blue obviously goes off to this winding of the transformer, so you could replace that if you needed to. And the black is actually what's piggybacking over to the other capacitor. So potentially, if you needed to, you could replace that as well. So I'm going to try and cut these out now. Try and give myself as much remaining cable as I can. Okay. So that's the cables, and there's a little bit of slack on that blue anyway, and the black one there potentially it's easy enough to replace. I might see if I've got some cable to replace that with. Okay guys, so what I've had to do there is I've struggled for quite some time trying to get those wires into the new capacitors, and whilst I haven't cleaned out the old terminals, I think you can see the old capacitors were much larger on the terminal than the new ones, and I've been struggling to get the cables to go in. So what I've actually had to do is just drill those terminals out with a 3mm metal drill bit, just very carefully. And you can see they're still perfectly fine, but they're just larger than the hole that it comes with from factory. And also that black cable was just going to be, it's just going to be too short to reliably join these capacitors. So I've looked around, gone through my parts bin, found a bit of flex, just standard 3-core flex, and just taken the live core out of it. And if you look at it, it looks to be identical to the black cable, and the amount of strands look to be pretty much on par. So I'm happy that that's safe enough. I mean, that's good enough for mains voltage, it's good enough for this. So I've managed to twist those two cables together and pull them through. I've put a little bit of heat shrink on there. I'm actually just going to pop that over that soldered connection when that's done, and hopefully that will sort of support those cables and stop any issues. So I'm going to attempt to solder that down now and see how we get on. Okay, so I'm just going to add some flux just on top of that. Just had a little drip there, so I'll just, luckily that hit the plastic, so I'll just mop that up. And we'll just come in with a cleaned and tinned iron tip. So just re-tin that. What we're aiming to do is just try and do a really nice thick solder joint. Let's just feed that solder into all of that cable, but you want to make sure that you also solder to the tab to get the most reliable connection. So I'm just applying the heat to the tab. Okay, and that's that looks pretty good actually. So we've got a good amount of solder on the tab, a good amount of solder on the cable. That's not going anywhere. So I'll just let that cool, and then we'll put the heat shrink over that and proceed to the second tab. Okay, so normally I would just use a lighter for a bit of heat shrink like that, but unfortunately there's not a lot of room. I don't fancy hitting that with a lighter, so I'm just going to use a heat gun. I've got a really cheap old arts and crafts heat gun here, so I'm just going to hit that with that. Okay, so that was just enough to get that to shrink over those cables. I'm happy with that. I think that's going to look good. So that will end up sitting sort of there. And like I say, doing it this way, it's just a little bit safer that nothing can drop on the terminals or what have you. So I will move on to the next step. Okay, so the next step is, of course, going to be trying to put the next set of wires on this capacitor, which are the white wires. So I've just stripped them back a little bit. It is quite tight, but I've got a little bit of heat shrink on there. And I'm going to try and solder that wire on now. can just get that heat shrink to just sit a little bit further back. There we go. That should be adequate for what we need. So it'll be the same principle. I'll just come in with a bit of flux over those wires, the tab, come in with the iron, which is currently at 320. We want to have solder bridging the gap between the cables and the tab itself, and you can see that's successfully happened. It's not the neatest, but at this stage on this part of the build, it doesn't have to be the neatest, it just has to be mechanically sound. So I think that looks fine. So we'll just let that cool, put the heat shrink over it, and move on to the next capacitor. Okay, so as you can see, I've successfully heat shrinked both cables on that first capacitor now. I think that should sit fine there. I'm now trying to do the next one. I've got a little bit of heat shrink there. And I've just pulled the cables through, bent them over. We'll just add some flux again. I have to rip off a bit more solder. The iron is running quite hot. It's running at 320 to do these. So I'm just going to tin up that tip. Just bring that iron in. Just add a bit of solder into that cable. And I'm going to try start to feed it in at the base. Because what we want is to get it all over that tab again. That's looking good. I just want to add a bit more. Try and get it to flow up and into those cable strands. Yep, I think that should be okay. And again, we'll let that cool off, pull that heat shrink up, and move on to the final tab. Okay, so as you can see, that's now all soldered in, heat shrinked as well. Now these cables will be a little bit shorter than they were, so there'll be less slack perhaps. It might be harder to refit, but I think it should be okay. So the idea now is to just sort of push them up against the ends of the assembly, get it nice and tight, and then we'll pop the foam spacer back on the top. And obviously the end one won't go where it should be, but we'll put it there, and that should stop any rattling. And then we need to try and refit the cage. So I'm going to go ahead and try and do that now off camera, and I'll be back with you in a moment. Okay, so for me, I've been able to clip it in at the back, but it will not clip in at the front. And I've tried to push the capacitors as far forward as they'll go. I've tried to rotate them a little bit, and it just will not click back in. So the way I'm looking at this is I think this piece here is just pushing a little bit too tightly on those solder lugs for my liking. So I'm going to just file a little bit of this plastic cage off, making sure it's still hopefully snug, but not that snug that it won't actually click shut anymore. So just going to try and do that, and I'll be back. Okay, good morning guys. So it just got too hot in here last night. The time of year we're just getting hit by a heat wave, and it seems that Bristol is or the southwest is just so hot at the moment. It was 31 degrees in here last night, and I was trying to keep the window shut to stop background noise, and I just couldn't keep going. So we're back on day 4 now. I've done a little bit of filing of the plastic casing, and you can see it's still quite tight to the terminals, but now I've been able to reassemble it, been able to get it to click shut, which is what it wasn't doing before. And I've put the pieces of foam in. I could have used some spray adhesive perhaps to re-glue them, but I decided that, you know, this isn't going to be moving very far once it's reassembled. So as far as I'm concerned, once it's screwed back in, that's going to be absolutely fine. Those capacitors are not going to be wiggling anyway. You know, they're not quite as well fitting as the other ones because they don't go all the way across. But you know, they're not going anywhere. So I'm happy with that. So as we discussed yesterday, I worked out the colour scheme, and I may make a picture of that and put that in the source information. I also emailed Martin last night just to ask about the polarity of these capacitors, and I'll pop that picture up on the screen now just for full disclosure of that. But essentially, yes, this is going to be the negative side, is what he told me. So thankfully those have been soldered in correctly. So this has all been reassembled. I've put the screws back in now. So as far as I'm concerned, this job is done. Okay, so we're fast approaching where we can reassemble this now. So we just need to clean the thermal paste off of this component, clean that up, reapply the paste to it, and then reattach that into the amplifier body, and then we can start to reassemble. So I'm going to clean this next, and then we'll proceed with the reassembly. Okay, so I'm just trying to do a dry run of how this all goes back together. As you can see, I've cleaned this part, and I'll be ready to put thermal paste on that shortly. But I'm just looking at the orientation of these cables, and they should go through black, red, yellow, because actually when I looked at the photograph from the other side, from left to right, it's yellow, red, black. So if we put these through in this orientation, obviously when I turn it round, that will be left and it'll be yellow, red, black. So those will go through in that order. In terms of where they go through that hole there. You can see where the screwdriver is going, and it's very fiddly. It's not going to be easy to show on camera. So what I'm going to do is I'll get this thermal pasted up, get these cables pushed through, and show you how that looks. The other thing to note is it appears that all of this basically sits on top of the speaker cable. This fits sort of down in that area. So lay that out first, pop that in next, and then proceed. The only other thing to mention at this stage is the connectors. I'm sure my connectors are in good health, but it doesn't hurt to actually spray in a little bit of the deoxit. So I'm just going to spray a little bit in the pins. You should use more of the contact adhesive cleaner than the fader one, but it's all the same sort of thing. So I'm just going to do that and then start to reassemble. Okay, so the eagle-eyed amongst you might realise there's something slightly odd. If you look at the screws that are holding the PCB into the casing, you'll see that bottom one there. It's really nice and tight in there. But then if you look at this one, you can actually see that the screw has missed the casing completely, where it's not lining up. So I'm just going to, apologies if that's out of focus, I'm just going to try and back that screw off and see if I can correct that. Okay, so hopefully you can see now that screw is sat in the casing nice and flush. And what I did is I just backed all the screws off on the back, adjusted those brackets ever so slightly, and I managed to get that one to sit in nice now. So just something to bear in mind. Okay, so hopefully you can see now that I've reconnected all of the cables, connected that small part back to the body of the heatsink. I've also pulled through those cables at the bottom there. I ended up pulling them through one by one to make sure that they went through in the right order. And what I'll do is I'll now gently try and move this a little bit more towards the body and try and pull the slack through. And then of course we need to put the clip that clips the cables back to the body in, and I'll do that next. Okay, so I've just been trying to work out where the little clip had to go, and the best way to explain it is that there's 3 cable ties and then there's 1 cable tie, and you need to go in between that 3 and that 1. And you may remember earlier in the video I said about it doesn't go over all of the cables, so just make sure that you get it over the cables that are relevant to how it goes back together. So I don't know if I'm going to be able to show this, but we'll try and clip that back in. And yeah, that is it. So what we'll do now is you would just carefully try and poke these cables back to where they were, because they all sat relatively low in the assembly. And then you can put the transformer back into the casing. Okay, so apologies for the shaky cam here, but it's the only way I can really do this. So I'm trying to get the transformer to go back in now, and I've rotated the body into this orientation. And what I'm going to do is I'm actually going to tape the cables into that part of the amplifier, and it will become apparent why in a second, because then hopefully it should lift into place quite nicely. Okay, so I've placed a piece of tape over the cables and they're holding in on the back there nicely. And what we're going to do is we're just going to try and gently lift the transformer up into the body. Just try and get the right angle there. And then I'm going to rotate the body. And now just try and slide it back in. There we go. Just tilt it back slightly. And you can see that's now the transformer back where it needs to be. You can also hopefully see, I don't know, I can't quite see the camera, but there isn't a lot of room. There is not a lot of room, to the point that you may notice there's a slight dent in the metal there, and that's actually a machine mark to make that fit. It slides down in that rebate. That's how tight that is. Make sure that there's no cables pinched. Make sure that the cables are sitting where they should sit. Give it a little wiggle. Make sure the transformer feels like it's nice and flat. And now what we'll do is we'll bring the washers and the screws in, and we'll screw that transformer back into place. Okay, so I've just placed 2 of the screws in and just started them off to make sure that the transformer doesn't fall out on me. And we'll just do this bottom one here. And all you've got to do is just slide it in through the rubber bush. And just be gentle with it. Make sure it bites okay. There we go, that feels fine. And we'll just do them up incrementally. And then just on this top one here, don't forget that this would be the one where you have the cable support there. So we'll just start that one off in there. Okay, so I've just checked the footage of when I disassembled this, and it's actually really beneficial to have that footage, because it's not that side, it's this side. So I just need to take both of these out and switch them around. So I'll do that now. Okay, so as you can see, I've screwed those in now. They're tight, the transformer is sitting nice and flat, and what you're aiming for is that the core there should be relatively flush with the heatsink, which seems to be the case here, so that looks fine. So what we'll do, like I say, we've got the cables here, and we will just feed those around the edge of that transformer there. Same with the speaker cable. Just feed that around, and then just bend that support back over there, and that will hold those cables nice, because they come out around about here on the body, I believe. So that's now that job done. Okay, so we're close to approaching the end now. We've got the cables to the transformer coming through. We've got the body reassembled and all of the parts fitted, and you have access to the trim pots. And we've got the trim pot here and here, and we'll need access to those when it comes to calibrating this shortly. So what I'm going to do now is we'll move forward to soldering these connections back on. I'll replace my glass fuse, which obviously we looked at earlier and found out was blown, and we'll move on to calibrating the device. Okay, we're now trying to assemble the power cable back to the amplifier, and you may remember from near the start of the video we made a little bit of a mess of this, which was nothing to worry about, but it's just something that's got to be fixed. And you can also hopefully see that one of the tags is still full of solder. So what I'm going to do is I'm going to fire up the desoldering station, just clean this up a little bit, and then we can prepare to reattach the cables. Okay, so somewhat unsurprisingly, the cable couldn't take the heat required to desolder it. So I just removed that from the tag, and I've cleaned that up. I've just stripped the cable back a little bit. I'll tin that up shortly, and I'm just going to sit that, that's my solder line changing temperature there, sit that against it, pull the black cable through, and then solder them together on this side, and that should be more than ample. Okay, so I've just tinned the neutral wire there, and I've just pulled the black cable through the tab. Just going to add a little bit of flux to that. And we'll come in with the iron and some solder, just see if we can just get that to join back to the tab. Okay, so that's starting to look fine. So now what I'll do is I'll just put that neutral over the top of it and melt that in. I'll be back in a second. Okay, so that's the neutral done. It's not the greatest bit of soldering in the world, but I'm confident that it's safe. And we'll move on to the next two cables. Okay, so here you can see the old fuse and the new fuse. Initially it looks like the old fuse is fine. You can see that the fuse wire is there. So visually I probably would say there's no issue, but if we bring the pins in, you can see it is indeed blown. And if I do it on the new one, you can see that the fuse is not blown. So the old fuse is popped, so I'll replace that fuse and be back with you shortly. Okay, so as you can now see, the cables have been soldered back onto their tabs and the fuse has been replaced. The negative cable I would have liked to have looked a little bit neater, or the neutral cable, sorry, but it's not imperative. This sits obviously within that cover at the base of the amp and nothing can touch this, so I'm happy enough with that. The fuses have tested okay, obviously, and it's time to move on with the next step. The next step will be reattaching the door. Okay, so I've been at the parts bag and I've got the screws out, the spring and the screw that holds the thermal sensor. And as I said when we disassembled this, you can see in that bracket there's a little groove which is designed to get to the back of it, and what it looks like is it just squeezes it and pinches it against it. So you need to make sure you get that around the back of the sensor, and there's no easy way to do that. You've just got to sort of feel for it. So the idea is get it in as flat as you can there. You could potentially push down on this a little bit to get some additional clearance. Just slide it in. And there we go. That will be behind that sensor. So that's how you reattach that plate. Next thing to do is just pop the screws back in. And you want to just put these in loosely, just until they're all in and you're confident that everything is where it needs to be. As you can see, this isn't quite where it wants to be. We'll find the thread somewhere. There we go.
the last screw up top.
Okay, so just bringing those down finger tight. Not even finger tight really, just touching. Now what we'll do is we will attempt to put the screw in for the sensor. It feels to be biting. If we're lucky, we may be able to see behind it. No, I don't think we will. But no. But what you will be able to do is you'll be able to feel. So you're feeling to make sure that that is over the sensor, which I can feel that the plastic is behind it. So I'm absolutely fine with that. So I will just bring that up to tight, which feels to be about there. Yep, happy with that. So I'll just bring those tight as well. We'll just wipe this down, remove any dust or what have you. And now we need to refit the door. Now, just before I do refit the door, I will just clean these connectors. I'll just spray a bit of deoxit in there and in that one, and then we'll reassemble. So I'll be back with you in a second. Okay, so I've used some deoxit on those connectors and I'm happy that that's all gone through and just evaporated a little bit now. So now we need to reconnect the door. I've given the door a little wipe off as well. And what you want to do is you want to hold the door sort of at this angle and then worry about the ribbon first. So what we'll do is we will actually move it over to this angle and we'll try and get that connector just like that, and then we'll just try and line them up and then just push him on just gently, just a little bit each side. Just going to rotate it a little bit so I can see better. And then what you want to do is just push it all the way on. Now I'm not sure, don't think that's, there we go. There we go. Okay, so you can tell it's all the way in when it's basically just under flush with that that panel there. You can see that. Okay, so once we've done that, we'll lower the door down to where it needs to be. I'm going to try and get the top corner just over but not on, and I'll try, there we go, pop him on. I'll just see that ribbon won't quite reach, so I'm just going to ignore the ribbon there. So I've got the top hinge on and the bottom hinge is not on, and what I'm going to do is I'm just going to push that a little bit. There you go, you can see that's it. We will connect that ribbon up now. There we go. And that's the door back on. That's of course with the exception of the clips in the front there and the central spring. But I'm actually not going to worry about that just yet. Just in case we have to disassemble it all. I don't want to keep putting stress on these fragile plastic components. But that's how you reattach the door. Okay, so we're almost at the point where we can plug the amplifier back in. However, we need to connect the multimeter up in order to test for voltages. So what we're looking at here is we're looking at the 100 ohm trim pot, which is R95. And based on the instructions, we're looking at adjust no load current whilst amplifier is cold and with no signal and no speakers attached. Adjust to 30 millivolts DC across 1 R103 and 1 R104. So what we're looking to do is we're looking to now finally tape up the ends of the speaker cables, just so that you know that they're safe and they're not touching anything they shouldn't be. We're now looking at having the amplifier turned round, and on the back of it you will see where those connection points are, and we will use these little pincers to latch onto that, and we will use this insulated screwdriver to adjust the trim pot. Ideally you would use a plastic tool for this, however I'm happy to use this. Let me get the shot set up, be back with you in a second.
Okay, so I just thought this was something interesting which I would just touch on before we actually get to the demonstration of how to do this. On the left hand side here is the Penta 1 service manual, and on the right hand side is the Penta 2 service manual. And when I read this the first time, I followed the instructions from Martin, and I also looked at the instructions in the Penta 1 manual. It was a little bit vague. I didn't quite understand where perhaps to connect the multimeter. And interestingly, the Penta 2 manual goes a little bit further, and you can see that it says connect the multimeter across the two resistors that is from the emitter of TR32 and the emitter of TR27. So if you had any confusion over which side or where exactly to clamp the meter on, the second service manual actually does a lot to clarify that. I just thought that was an interesting point.
Okay, so you can see I've got the amplifier on its side here, and I'm just getting ready to show you what we need to talk about. So going back to that service manual, it said the emitter of TR32 and TR27. So TR32 is there, and you can see the emitter is the top pin, and TR27 is the lowest transistor there, just at the bottom. Can't quite see the label because it's actually under the bracket, but that is what that is. And the emitter pin is the furthest in one. So what we can do is we can just use the multimeter on continuity, and we can just touch the emitter, and we'll look at this resistor 104. We can see that's the side where it's connected, so that's where you want to connect. And the same principle at the bottom, we'll touch the emitter there, and that's where you want to connect there. So I'm going to use these little connectors here, and luckily the resistors, they've left the legs nice and long, so you've actually got something to clamp onto there. If I can actually see what I'm doing, there we go. And we'll do the same thing down here. And now you've got a nice secure connection on both parts. And what we'll do is we'll just connect those to the multimeter like we did earlier in the video. And we will move the meter across. So it said 30 millivolts. So if we put it on the DC 200 millivolt range, we should see, or we should get a reading on this which we'll have to tweak to 30 millivolts. Okay, so just to recap, we now have the cable and all of the fuses connected. We now have the amp fully reassembled. The top is off, so be careful. We have the door connected. I've switched all of the switches to minimum, and if it was a Penta 1, you would switch it to, I believe, the off position, and the Penta 2 has an off auto position as well. We've got the multimeter connected up. I've got a extension lead ready to plug in, and I'm ready to switch this off if something does go drastically wrong. We've got the tool ready to adjust, and what I'm going to do first of all is I'm just going to plug it in and turn it on with the switches off. And I'm looking to see if the red power light or red standby light comes on and stays on, because my initial fault with this device was that it would blow the fuse in standby. So let's connect this, okay, and we will turn it on, and fingers crossed I've not completely destroyed it. Okay, so the red standby light has come on. Hopefully you can just see that glow. Just see the red there. And it's actually staying on. So it's looking like the initial problem with those fuses blowing, it's not blowing, which is good. After all this time, it's good to see that. So what we'll need to do now, so we'll need to turn the amp on, and we'll need to quite quickly try and adjust that setting for the 30 millivolts, because when we turn the amp on, you may hear a bit of buzz, a bit of overdrive on it. So let's see if we can do that now. Okay, so the amp's on, and that's driving it way too high. That's going up, so I'll go clockwise, it's going down. We want to go down to 30 millivolts. Oh, gone down a bit too much there. Oh. I find there's not a lot of room for error here. Okay. That did go to 30 briefly, and then obviously it's gone back down. I'm just going to leave that for a second, and then we'll just try and tweak that up a little bit. So it seems that anti-clockwise goes up and clockwise goes down. So there we go, I've just touched it and it's just gone to 30.5 there. And the amp's turned off. So the reason the amp is turned off there is because, of course, there is no source. So in order to trigger that, we will just switch the amp back off. It's interesting that when you change that switch, it does ramp up briefly. You should see that go down to 0, I hope. There we go. We'll just initiate power back to the amp. See it coming up. And as I understand it, the voltages will fluctuate with heat. So we'll just keep doing this test a couple of times just to see if we can get this to stabilize. Because it doesn't matter what it is when it's cold as such, it matters what it is at operating temperature. So let me just run through this a few times and we will see if we can get that voltage to stabilize. Okay, so you can see that it's pretty stable at 29 something. Because I don't have a source connected, it will just shut off too quick. But you can see it's 29.7 there, and if it keeps going, there you go, 29.8, and it's shut off. So I think that's going to stabilize it 30 millivolts quite nicely now. So what we'll do is we will move on to the next task, and I'll be with you in a second. Okay, so you can see now we've got the multimeter connected, and I've actually got it connected to the speaker cable output at the back there. You can just about see the cables there. So I've got that connected with the sort of crocodile clips, alligator clips there. And ignore the reading that's on it at the moment, that's not important. What is important is that be very careful, obviously, when there are live parts, you don't want to go touching any of that. But we'll just turn the plug on again now, and we just want to see what this is. And we want to set this down to 0 volts DC plus or minus 50 millivolts. So the idea is try and get it as close to 0 as you can, but don't worry if you don't. So we'll just turn that on now. We'll just bring the amplifier on. There we go. You see that's it, 3 millivolts. So it's not far off. Just see. Ooh. So I think clockwise. Seems like I was very close. Anyway, to be honest with you. Okay, I think I might be happy with that. Let's just try and check that again. Yeah, it's under 10 there, obviously, so it's at 3.8. And that will fluctuate with temperatures, of course. So I think I'm happy with that. It should be 0 volts plus or minus 50 millivolts, and at the moment it's plus 3.6. So I think that's well in tolerance, and I'm happy to go back and check the 30 millivolts, make sure that's still correct, and then we'll proceed. So I'm just going to check the 30 millivolts again here. Oh, I think my switch is a little bit faulty on the lid here, but once it's set, it's set. You can see it's a little bit under. It's shutting down quite quickly now, which is somewhat interesting, but the Penta 2s always are very good at shutting down quick when they don't notice a source. So it's under, but it's coming up. I think it's going to be fine. The next stage for me would be perhaps to try and connect a source and just give it a few minutes to burn in. So we'll just try and do that now. Okay, so just excuse any background noise. I've just fired the old desktop up here. I'd rather blow that up than my Mac if I can help it. So I've connected the audio lead there from the RCA to the headphone socket. And we'll just turn the amp back on. Of course, it's going to be in standby mode. Actually, I tell a lie, it's in auto mode. It's turned straight on there because it's detected a signal. And we can see that the multimeter is sat at 21 millivolts. So we will just keep monitoring this and see how it goes. Back with you in a moment. Okay, so it's been about 10 to 15 minutes. And the multimeter did actually go up to bang on 30 millivolts. I'll put the picture up now for that, just so you can see that. But strangely enough, it's gone back down to 29.9. There's nothing in this world that will convince me to tweak that trim pot now, because it went up to 30, it did not go above it, and now it's just started to go down just a hair. So as far as I'm concerned, that's within the guidance, that's correct, and I'm ready to button it back up. Okay, so I figured whilst we've got the amp actually in this orientation, it makes sense to put the cover back on. So we've got the amplifier unplugged. That's now unplugged. So you've got a plastic sort of dimple there, and you've got a hole in this for that. So the idea is that goes in there, and then like I said earlier, the cable connections are actually protected against that hard piece of plastic there. So what we'll do is we will just bend those cables a little bit and just bring this in, and we're trying to line that dimple up and get those bits to click over, and there we go, that's that done. Okay, so then it's just a simple case of gently refitting it, just like that. And there must be, yeah, I'm just out of alignment somehow because the, oh, I know what it is it that switch? Let me just change that. Okay, so it was just some clearance issues just with the cables there, so I just had to rearrange them underneath it slightly. And we can see that's now going to sit nicely. You can see that the screw hole lines up nicely, so we'll just pop that screw back in. I'll just stand up to do this. Just do that one down tight enough that you're happy. And that is how you refit the base plate, or the base cover. Now we'll fit the base plate. Okay, so as I said earlier in the video, if you take this plate off, you'll forget to put the cable through it, so this is that time. So what we'll do is we'll just feed that cable through the plate, so that, and then we'll just bring it up, just gently offer it up to the amplifier, and then I'll just change view to see if we can see those screws going in. Okay, so I've just been into the parts bag, just emptied the parts bag. We'll just have a go at using the flat ones first, which go down into that plastic bracket. So there's two of those. Let me just find the other one. There it is. So just, if I can get it through the hole, there we go. And then of course it's the sharp ones at the front. So I'll just see if I can get one of those to start. That feels like that started. So we'll just try and start that one off into the plastic bracket for the power cable. Sorry about the poor angle there on my hand. Yeah, so I don't know what was going on there, but that is definitely screwing in now. So that, yep, that feels tight, tight. 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 So we'll just flip the amp over and we'll do the same on the top. Okay, so now we've flipped the amp over, and obviously, as you may recall, we haven't refitted the door. So we've got the spring, and all you do is you just pop that into the plate and just try not to have it spring out. There we go. That's fine. And then we just push, push, and in. And that is how you refit the door. Okay, so it's a similar sort of process with the top of the amplifier now. I'll just take my clips off. We have the top, and we'll just feed the cables through one pair at a time. And then we just need to fit the top. Now there is a groove for the cables, and I'll just see if I can get a better angle to show you that now. Okay, so hopefully you can see this. If I screwed this down as is, it would crush the cables, because there's actually a groove. There you go, you can just see the groove there. So you just need to make sure that you get the cables to sit in there nicely, and then we just screw that top down. So I'll just do that now. Okay, so what we have now is one reassembled Penta amp. All the door still works. And it's now time to test it one more time, and then we will pop it back on the speaker. So just plug the amp back in, just going to see if it turns on okay. Comes straight on to standby. And it's on auto mode, but there is no source. So I'll take it to off, move it to source. We have power. And that's one working amp. So let's stick it back on the speaker. Okay, and we are back we are back where this all started 4 days ago. So we've got the Penta speaker, and you can see how the connections are on the base. So I'm just going to screw the terminals out as far as I can, just so I've got a nice amount of room to get the cables in, and we will just gently try and bring the amp into the speaker, obviously making sure you get the orientation correct. But if you got this far, I'm sure you're capable of doing that. And this is a little bit fiddly. You have to line them all up. I'll just see if I can get a better angle of this. Okay, there we go. So now we have the amplifier on the spokes. It's now just a matter of reconnecting the cables. It's personal preference, I like to do the DIN connector first. I'm just trying to see which way around that goes. There we go. And then we'll just do the speaker cables. Of course, got the one that I put the felt tip marking on. Okay, so that's all the connections done. So now just push the amplifier back. Just make sure that you're not crushing any of the cables. And then we will refit the bolts to hold the amplifier to the speaker. Okay, so now we'll just spin the nuts back on, just by hand. And then we'll just use the socket just to bring them tight. And I'll just alternate because I just want to try and bring it in as square as possible. And there we go. It's now time to put the bass on. Okay, so now it's time to put the bass on. So we'll just feed the power cable down, back through the bass. Okay, so I'll just bring the bass up. Just watch for the power cable there. And there we go, that's it on. And I'll just get some of the nuts just started, just to hold the bass. And then we'll just tighten them up. And that is the speaker reassembled. Okay, so here we are. We're back with the Beolab Penta 2. I've got it connected up to my laptop. I've not heard this at all yet since the rebuild. The last time I heard this speaker play was in mid-November last year, so it's been a little while. I'm going to turn the plug on. The amp may bang. I don't know if anybody else has this problem, but my Pentas, when I turn them on, they seem to pop the first time. So may get a loud pop. The amp should turn on and then we can try some music. Okay, so there was no loud bang. The amp should be in auto mode, so I'm hoping if I trigger some audio from my laptop, it should turn on. I've got it on low, so we'll see how this goes. Slight pop, nowhere near as bad as it was. that is some pretty earth-shattering bass coming out of that. It just feels good to hear the speaker again. So I'm going to stop this video. I'm going to play some music that I actually want to listen to, and I'll report back in a moment. Morning guys, Shaky Cam back. This is day 5, I believe now, it's Wednesday. So just a bit of bonus footage for you. This is the other amp on the other Penta too. It does work fine, but somebody's been at this. The plug has been replaced, and it's got a 13 amp fuse in it. The switches are missing, and they were taped to the underside of it, so I don't know what that's about. I'll have to get that out and have a look. And finally, there's a barcode on the bottom of it, so obviously this has been in for repair at some point, so it'd be interesting to see what's going on in here, and if anything interesting comes up, I'll let you know. Just another quick bit of sort of bonus footage here. I thought I would clear out my gun before I do the second amp, and I just wanted to show you how much solder got removed from that last amp. And you can see that is a humongous lump of solder. So much that it's literally clogged the end of the spring, so I'm gonna have to smack that out.
Okay guys, so we'll just look to round up this video now. The speakers have successfully been rebuilt. They are both now cleaned, polished, and in my living room. That's the picture you can see on screen now. I will be doing a follow-up video showing how they work and talking more about them, but I think the basics that you need to know are, they sound absolutely brilliant. I wish you luck with your amplifier rebuild. Thank you for watching.